My name is Mukhtar Mohammed Amin. I am a research assistant and PhD student in computer vision. Today I am presenting to you my course about liver segmentation using Monai and PyTorch. By this course we will start by defining what is UNet. Then we will talk about how to prepare our data. We will start by downloading them, preparing them, and doing the pre-process. Then, as I told you, doing the pre-processing to data and applying all the transforms that we need to do for medical imaging using Monai. Then we will talk about all the installations that we need to do from Monai, PyTorch, CUDA, cuDNN, etc. etc. So we will talk about all the packages that we need from the Python packages into the other softwares. Okay? Then we will talk about what are the common problems or errors that you may face using Monai for medical imaging, of course. Then we will talk about the training part, which script that we will use, how does it work, etc. etc. Then after that we will talk about the testing parts. After finishing the training, we will analyze our data, not data, but we will analyze our model, and we will pass some testing patients and see what our model is giving us, if it is going great or not. And I will give you some advices how to fix or how to make your accuracy better if it doesn't go well at the end. And after that, at the end, I will show you how you can just clone the GitHub repository. If you understand everything I will say in this course, you can just clone the GitHub repository and try using the scripts. So I will show you how you can clone it, how to install the different packages, and how to use all the scripts that I am providing you in this GitHub repository. A little bit about UNet. So UNet is a deep learning architecture for semantic segmentation. It was created first for biomedical imaging. So if you are interested, you can read their paper. So in their paper you will see that this architecture was created for biomedical imaging, and because it is a great architecture and it has a good accuracy, they started using it for the other image segmentation tasks. So now let's talk a little bit about something else, and we'll go back to the architecture after. Now, maybe some of you doesn't know what is the difference between image classification, object detection, or image segmentation. So the image classification, as you can see, it is the easiest task in deep learning. So image segmentation means the image classification, means that if you have an object in an image, so you just need to know if there is that specific object in the image or not. So in this case, we have a cat in the image. So the output of your model or classification model will be a probability, that means that you have a cat or not, with a probability from 0 to 1. More closer to 1 means that this object exists in the image. But that's all what you need to do. This object exists or not. Then there is the object detection, which means that you need to create or to draw a bounding box in the image or localize the objects in the image. Not only saying that this image contains a cat, but you need to draw a bounding box, which means we need to localize it in the image. So this is the object detection. Then the image segmentation means that you need to draw a mask in the image to refer to all the pixels that have the same object. So in our case, we need to specify which pixels have the object, which is the cat. So in this case, we need to draw all this mask to refer to the cat in the image. So this is the image segmentation. Then in the image segmentation, there are two types. There is here, the first type is the image segmentation, which is semantic segmentation, and the second one is the instance segmentation. Now here in the left, you can see this is the semantic segmentation. Means that you need only to segment how many classes you have, which means here we have only two classes. We have the class person here and the class background. So that's all what you need to do in instant segmentation. You don't care about how many people you have or how many other objects you have in your image. You don't care about that. You need only to segment the classes that you have. Here we have class person, class background. But in the instance segmentation, don't only you need to segment the classes, but you need to specify how many objects or how many people here we have in that image. So in that case, we have person 1, 2, 3, and so far, which means that you need to segment the person and say this is a person 1, this is person 2, etc., etc. So if you have 2, 3, or more than that classes, so and in each class you have more than one object in the image, so you need to specify this is the object 1 from the class X, this is the object 2 from the same class, which is class X, etc., etc. So UNet is an architecture to do semantic segmentation, which means it will do only this type of segmentation. It doesn't do this type. You can see faster mask faster RCNN to do instant segmentation, but UNet you can use it only for semantic segmentation, and that's all what we need in our project. We need to do a liver segmentation, so we need to know where is the liver and where is the other parts of the body, which is the background. So we don't need to have, there is no two livers in the same person or something like that. So that's all what we need. Segment the liver and the background. So for that we will use UNet here. Now let's talk a little bit about the architecture. The architecture is in the shape U, for that it is called UNet for this shape, okay? Now UNet, you need to know that UNet is one of the easiest architectures in deep learning. There is nothing hidden or there is nothing difficult on it. You can see that there are only convolution layers and followed by a max pooling. Convolution layers, max pooling, convolution layers, max pooling, and here it will do up convolutions and max pooling, up convolutions, etc. But why they are doing this? Because UNet is divided into two parts. There is the first part called the encoder, which is this one here. The down, we can call it the down blocks or the down part here. For that it is called the encoder. So we don't care about the names, but this part here it is going down, which is the encoder. So if you look clearly to this part, it is looking like a normal image classification architecture. Okay, there is nothing new. There is only here convolution blocks, because this one is called a convolution block, but it is a convolution layer followed by max pooling, convolution layers, max pooling, and each output of these convolution blocks there is a ReLU function. So if you understand what is happening here, you can see that this is a normal image classification architecture. And here, this is the final output that we can put it, we can pass it by a softmax layer or something to see the output, but this is not what we need here. We said that our output that we need it to be a mask with the same width and height of the input image, so that we can specify each pixel and its class, which means pixel 1 goes to class 0 or class background or class lever or something like that. For that, we need to do this part, which is called the decoder. So this decoder will take the feature that we have extracted in this encoder part and use them here to build the output image, so that you will have each pixel, instead of having only one probability for all the image, no, you will have probability for each pixel, so that you can classify each pixel how many to which class it goes. For that we call it pixel probability, not a normal image probability or something like that. Now let's take an example about how does the output of UNet look like. Here is, for example, this is the outputs that I used for my project, which was a tumor segmentation in the whole body. So I took just this example to show you how does it look. Now, this is the input mask, which is the label or the ground truth. You can call it as you like. So this is the input mask. I didn't have the time, not time, but I didn't have the space to put the image as well. But I think this is enough to see. So this is the mask that you have. Now, these are the two outputs of, it is one output with two channels of the UNet. So if you have this output here, or this output channels differs from how many classes you have. So if you have two classes, so you will have two channels. You have three classes, you will have three channels, etc., etc. Each channel will have the pixel probability for a specific class. So in my case, I had two channels, the background two classes, sorry. the background class and the foreground class, which has the tumor. And in our project here, we will have two classes. The first class is the background. The second class will be the liver. So this was my outputs. This is one of my patients. So these are the channels for one output. This one refers, this is the output 0, this is the channel 0, this is the channel 1. So this one refers to the background, and this one refers to the foreground, which is the tumor. Now, the values that you see here, more the color closer to the yellow means that the value of these pixels here is closer to the value 1, which, because we said we have pixel probabilities, which means differs from 0 to 1. So more we have the value yellow, more we have that pixel goes to the class 0, which is the class background, and more the value goes to the purple here means that the value is closer to 0. So if the value is closer to 0, so means that these pixels doesn't go to the class 0, which is the class background. And here the same thing for this part, but this channel is the channel for the foreground, which means for the pixel for the I forgot the name. This channel is for the tumors. So these values here, you can see that they are closer to the yellow, means that these pixels contain a tumor, and all these pixels doesn't contain tumor, which means these pixels are background, and same thing for here. So you can use only one of these channels to specify your predicted or your final prediction, or you can use both of them and use a argmax, or you can use a softmax, or anything you want to apply, or only a simple threshold, and get the final output. So that's what we will do in this course. So but all these parts will come later after doing the training and etc. But just I am showing you how does the output of UNet looks like. So you will have, this is the label, you will have two channels, or how many classes you have. In our course we will have the same thing, two classes, the background and liver. So you will have pixel probabilities of each pixel, and using argmax or a simple threshold, you can get your final binary mask, which is like this. These values are 1, these values are 0. So this is a binary mask, or false and true. You can use as anything you want, depends to how you are doing the threshold or something like that, because if you will do a normal threshold, so you have false and true. If you are using a normal argmax, so you have 0 and 1, but it is the same thing, you don't need to care about that. Now that's it, and thank you for this part, and now let's do some installation. Now, let's talk a little bit about the software that we will need in our project. We need only these 4 softwares, which are, we need Python, VS Code, 3D Slicer, and ETKSnap. I am not talking about the dependencies, like Python dependencies that we need, like Monai, etc. But all these dependencies, we will not talk about them now, but we'll install only the software that we'll need. The first one is Python, as you know, because we'll execute our code using PyTorch and Monai, and of course using Python, not C++ or other programming language. Then we need the text editor, where we will need to write our code. For that we need to install VS Code. So this is my choice, and you can use any text editor you want, but my preference, I preferably need use VS Code. But if you want, or if you prefer using another one, or maybe you want to use Jupyter Notebook or something like that, it depends to you, and it doesn't change anything. Just I am showing you what I will use in this course, so you can follow me if you want. Then we will use 3D Slicer. So this 3D Slicer we will use only to display our data, and we'll use it as well for something else. We may need a conversion that cannot be done using Python, but we will talk about this in the processing or in the pre-processing part. But for that we will need this 3D Slicer software. After that we will install ETKSnap, because we will need this type of software. Maybe we will not use it in this course, but maybe you will use it, because I will show you how you can do the segmentation or correct the segmentation using this ETK snap, because I don't know if you will use the same dataset that I will use, or maybe you will use your custom dataset. So for that case, maybe you don't know how to segment or how to correct your segmentation. For that, we'll use this ETK snap software, and of course I will show you how you can use it. For now, I have all these softwares installed in my computer, but I will show you how you can do it by your own. Now let's go here. We said that we need to install Python first, so we have python.org, then slash downloads. As you can see here, this is the latest version, which is 3.10. If you want to use this one, it depends to you. If you want to use another version, so you can just click on Windows, and all these versions, they are here. But don't worry about this. Maybe I will show you in the following videos when we start coding and when we will start installing the dependencies. I will show you that sometimes we will need to create a virtual environment, and where we will install a specific version of Python in that specific virtual environment. But at first, we'll install one of these versions, and maybe you need to install the 3.10. Doesn't matter, because maybe we'll use it only for some not even pre-processing, but we'll use it for preparing the data, because we will pass by 3 or 4 phases before doing the training, because there is pre-process, but before the pre-process we need to do something with this data, because you know that medical imaging are very hard to use or to treat. For that we need to do some preparation. After that we will do the pre-process, because these are two different processes. For that I am saying prepare and pre-process, because I want to say that there are two different types. Okay, so if you want to install, for example, Python 3.10, just click on this, or you can just go here in downloads and download Python 3.10, and just save it anywhere you want, like this, and it will be downloaded. Of course, my internet connection is a little bit slow, for that I need to wait a little bit. So just you need to execute this command and follow all these steps. I don't want to do it because I have already Python. I have a lot of versions of Python installed on my PC. For that I will not do this here, but you can see that you just need to here, because in my case I have already Python, so I need to uninstall it, then install it again. But for you, you will have only a button to say install and follow up all the steps, and it will be installed. So I will cancel this, yes. Then here we said that you need to install Python. Here is, so after that you install it. Now it is done. Now we need to install this text editor, which is VS Code, and of course I have it already, as you can see, in my PC, but I will show you just how you can download it and maybe try to install it. So VS Code download, like this, and you go here to code.vscode studio, and there is this link. Both of them are official, so you just need to click here. Now we have Windows, and it depends to which operating system you have. So in my case I am using Windows, so you can just go here, Windows and Windows 10, and click on download here, or it will start the download by itself. But if it doesn't start, you can just click here on download. Okay, now you need just to install to download this one. Maybe it will take time, because as I told you, my internet is slow these days. So just download this and install it, and follow the steps as you will do with Python, and it is very easy to install as any other software. I will just cancel here. Now after that we don't need this for now. Now after installing this VS Code, let's talk about 3D Slicer. 3D Slicer is the same thing. It is a free software that you can find here. 3D Slicer download, like this, and this is the 3D Slicer download. Just check which operating system you want. Just take the stable release, don't take this one. So just choose Windows, Mac OS or Linux, and for my case I am using Windows, so I need to download and install this one. But as I told you, I have already this software, so I will not go and install it again, especially my internet connection is slow. But you get the point. Download this and install it step by step. It is free and easy. Then after installing 3D slicer here, because I told you that we will need it for some preparation of our data and visualization, of course, as well. Then we have the ETK snap that we will use for segmentation. By the way, you can use ETK snap for segmentation, but sorry, you can use 3D slicer for segmentation, but I found it a little bit difficult, because you will see that ETK snap is easy, very easy. It is old, but it is very easy to do the segmentation than using 3D slicer. But if you have already used 3D slicer for segmentation, so you don't need to follow me doing this with ETK snap, okay? So I am telling you, with my experience, I tried to use 3D slicer and I tried to use other softwares for segmentation, but the easiest one was ETK snap for me. For that, I am presenting to you ETK snap, okay? And I cannot use ETK snap for the some preparation. For that, I need 3D slicer. So each one has its specific advantages and disadvantages. Okay, now let's search for ETK snap. Like here we have ETK snap. Now we have this, or we can just click on download. Downloads here. You can see even their web page is too old, but it is a good software, okay? So you can just choose, for example, Windows or all these versions. You will take the latest one, okay? Now you can use for Windows, Mac OS, Linux, or something like that. Depends to you and your operating system. So for me, of course, I will use this one, but I told you I have it already on my PC, so I will not take the time to download it and install it again. So that's all what we will need for our course. I am talking about the software. We'll go back after to talk about the dependencies. But for now, you need to install Python, VS Code. I will leave all the links in the description. So you need to install Python, VS Code, 3D Slicer, and ETK Snap. And after installing this, we'll go back and we'll continue doing our course. Now, let's talk about the dataset. I will show you how you can find some public datasets. Otherwise, if you have already dataset in your projects, then you can use it. But if you don't have, and if maybe you are trying to do this segmentation just to improve your skills, in this case, I will show you how you can find some public dataset. So the first source that I will show you, that it was helpful for me and it contains a lot of data, is the Decathlon dataset. So this Decathlon dataset, as you can see here, there is I think 9 tasks. We will go here. There is papers dataset. There is more things, but what we are interested in is only the dataset. So you just click here in get data, and you remember with me, you just write Decathlon dataset. You will get the first link here, but I will leave all the links in the description. Don't worry about that. But when you click here, go to get data, and it will open the Google Drive here, and you can see that all these tasks, as there is 10 tasks, as you can see here. So all these tasks means that all these are a group of data, which means it is ready. You will find the volumes with the segmentation, so everything is ready. Just need to download it and use it. But here you can see that there is brain tumor, there is heart, there is liver, as you can see here. There is hippocampus, there is prostate, and there are all these things. There is lung, etc., etc. And this one, as you can see here, this task 9, which is the spleen, which was used by Monai. So if you go to Monai website here, for example, I will choose it because our course is based on Monai, as you remember. So if you go here in Monai and you see their project that they are doing here, for example, we go to GitHub, and most of the projects and most of the tutorials that they are using here, you will find that they are using this data set. and you will see that because I found this decathlon dataset from Monai website. So when you go here, you will find this spleen dataset. Maybe you want to try it. I don't know, but in our project we will use the liver segmentation. So, but I am not using this one. You can download this one, and it depends to you and what you want to try. Okay, so for me, I found a dataset from Kaggle. I will show you as well there how you can find that, and I am sure that there are other datasets, but for now you can find the best ones here in this website. And in Kaggle, I will show you the dataset that I will use in this project. If you go here in Kaggle, go to datasets. Maybe you need to, if you want to search in general, you can write just healthcare images or healthcare datasets or medical imaging and found all the tasks that they have. Otherwise, if you are searching for the exact data that I am using or I will use in this course is liver segmentation. So just write liver segmentation like this. So here you will get all these results, but these are because I am saying these because there is this first part and the second part of the data that I used in my project in this course. So if I will open this and this in the another tab, you go here and you found all these segmentations, and these are the volumes. Segmentations are the labels, and these are the volumes. And you can see that they are not completed. For that, there is the second part that you will find the other volumes of the first one here. So you can download this because I have them, so I will not download them. But you can download this if you want to use the exact data that I am using. So you can download this first part and second part, put them in the same folder or something, and we'll go to them later. Now, after that, you choose your dataset. It can be this one, or other task. But what I want you to know is while using Monai framework, you need to have datasets with the extension Nifty. So it should be .nii or compressed Nifties, but you need to have the base extension Nifty. For that reason, you need to search for data that has Nifty, or you can search for data that can be converted into Nifty. For example, it can be an RDD or NRD, or it can be DCOM, or any data that can be converted into Nifty. Otherwise, you cannot use these kinds of data with Monai. For why I am saying this, because if you are using simple 2D segmentation, you can use anything you want and you don't need Monai. Because I am using Monai especially for the pre-process part, because you can't find a good framework that help you to do pre-processing as the 3D volumes in medical imaging. I couldn't find something better than Monai. For that I am using, because Monai is great thing. They are not paying me to say this, but it is a great framework for medical imaging. They have some problems and some things that they need to fix. I will talk about them in the future lectures or future minutes. But for now, I am saying that it is a great framework, but some improvements that need to be done. We'll talk about them later. So if you need to put this in mind when you want to use Monai, you need to have Nifty files. If you don't have a specific Nifty files, you need to find data that can be converted into Nifties. So how you can convert this data into Nifties? This is another question. So some of the extensions can be converted using Python. For example, like the DCOM images, if you have series of DCOM, because a Nifty file is a series of DCOMs. Because the DCOM here, I will show you an example. This one, as you can see here, this is all these DCOMs that goes to one patient. So all these DCOMs, each DCOM is one slice of a CT scan. When we combine them, all these DCOMs together, we get one volume. That one volume is one Nifty file. Because when you take one Nifty file and put it into the slicer or any other software to visualize it, you will see that it contains a lot of slices. So each slice is a DCOM file. That's what you need to know. I don't know if you know that, but I am just saying that. So, as I told you, try to find Nifty files or files that can be converted into Nifties. Now you get this data. If you want to convert them, for example, if you have decoms like these and you want to convert them into Nifty, you can use 3D Slicer. But I think that for this kind, because there is a Python the Python package does help you to do this conversion. For that, we don't need to use this. There is decom to Nifty package that you can use it, install it using pip install. But don't worry about it. We will do this later because now I am just talking in theory, but we will do the code to do this conversion after. For now, I am just telling you that you can do this conversion using 3D Slicer, but I don't recommend you because it will take time to upload or to load the data and save it. So don't think about this for now. But if you have, for example, NRD images or something like that, for that case, maybe you cannot convert them using Python. For that, you need to pass by this software here. Now, let me tell you something. How you can convert data using this. I will just show you how I did that. So what you can do, because I had a problem when I was doing some segmentations, I couldn't save them as Nifties. So I had segmentations or labels, they were in NRD extension. For that, I needed to convert them into Nifty. For that, I passed by this software. So now let's take, for example, this is a Nifty file. We don't need to convert it, but just to show you how you can do that. Imagine with me, this is an NRD file. To open it, just pass it and put it here in your software and drag and drop it in the software and click OK, and it will be opened as a volume here. And if I will scroll with the mouse, you can see here I am passing by all the cuts or all the slides which are already decompiled. Okay, so that's what I was talking about. When I am scrolling this here, I am passing by all the decom files that have been combined to create one Nifty file. Now imagine with me, this was a NRD file, for example. Now I want to convert it into a Nifty. What you can do, just put it here, drag it and drop it here. It will be opened, or you can just open it here, file open, etc. Now to convert it, click on save. Now just don't take this one and check your file here. You need to see, because this one is the project, you don't need to save it. So just save your file here. If you have multiple files, you can drag them all together here, and they will show you all the files here that you have been opened, and you with one click you convert them all at the same time. Okay, so here let's say that this was a NRD file. So here you can see that there are all these kinds of files NRD, like this one, for example. If imagine with me, our file was NRD. Now you want to save it as a Nifty file. So just click here, search for Nifty. It will be here. So there is this one Nifty, this one the same thing, but this one is compressed. I recommend you to use compressed so that you will save some of your memory. You don't need to worry about compressed files when you use Monai, because it will know how to. I will show you how to do that, because you don't need to worry about that. So I recommend you to save them as Nifty, which means nii.gz, which is compressed. So click here and click on save, or you can choose the directory where you want to save your file. Then click on save and it will save your file. If you have multiple files, just change them all here in the place of NRD, put Nifty and change them all and click on save. It will save them all together in the same repository that you want. So that was how to convert any file. I am not saying any, but you need to see here there is NRD, meta image, all these kind of files. So if you have dataset with these extensions and you want to use Monai, so you need to convert them into Nifties. So you need to pass them by this software, for example, and change them. Maybe you have some extension that doesn't exist here, so you need to search another software, or maybe there is a Python script that does that. So that's my recommendation. But if you find directly Nifty files or if you will use directly the dataset that I used here, like this one and this one, In that case, you don't need to convert anything because they are already nifties. Okay, so that was about the dataset. And in the next lecture or next minute, we will start doing some pre-process to our data. And there is something we need to talk about before doing the pre-process. But don't worry, we'll go step by step until the end of this project. Now, let's start preparing our data. As I told you in the last part of this course, I said that there are two different parts. There is the preparation of the data and there is the pre-process. I am calling them this because there is the preparation that we will do manually, and we will do it in another with script without doing the pre-process, because the pre-process we need to do it directly before the training. So before doing that, we need to clean the data, because medical imaging are little bit confused. We can't use them directly to our model or our segmentation or anything like that, because if we use them directly, we will have some problems and we will not have good accuracy, and even we cannot fix our problem, and we cannot even know where is the problem there. So for that reason, we need to do some preparation to our data before starting the pre-process or the training or anything that we will do later on. So, as I told you, there is the data here in Decathlon dataset and there is in Kaggle. Let's go here and I will show you that we will use this Decathlon dataset. I have already downloaded, prepared it, and everything I have done, but I will show you only with 2 or 3 patients to show you how does it work, and so that you will have an idea how to pre-process your own data. Okay, because if I will do the pre-process or the preparation of all the data, it will take time, but we don't need that, because when you understand how to do it for 1 or 2 patients, you can do it for all the patients. And don't worry about the code. I will provide you everything that we'll use here in these tutorials, so don't worry about that. Now, as I told you, you go here to get data, and it will open this one. And as I told you, we are doing liver segmentation, so this is the dataset that you need to download. As you can do just like this, click with your right hand and click here in download, and it will be downloaded and you can use it directly. Okay, now after that you will download this data. It will look like something like this, and after that you decompress it, it will be something like this. And when you enter, you will find all these files. We don't need them, you can delete them, but you will find 3 different folders. This one is image tr, which means images for the training, and this one are images for the testing, and this last one is labels for the training, which means you can see that there are labels only for the training images. There is no labels for the testing images. So in this case, it is easy to understand what is the liver, but in some cases it is not easy. But for now, we will not, in this course, we will not need this training. You can leave it here, but we will not need it, because at the end of our training, we need a label so that we can compare the label with the images that we have, with the output that our model will predict. So in this case, we will take only the images, training images and testing and training labels, and we will take few patients from the training. Maybe we'll take 10 or 20, because we have here, you will find that you have 130. These are only because it is redo it here after the compression, but in reality there are only 130 patients. So if you take 10 or 30 patients for the validation or for the testing, so not all of the, because the validation is different than testing. So because in our case we do training and testing, we will not do validation, because when you go to Monai tutorials, you will find that they are using the word validation, but I am not sure that this was the validation, because it is true that they will use that data during the training, but it is not validation, because they will not affect the training or the model. They use it only to calculate metrics and to test their model. For that case, we cannot call them validation. They are testing dataset, not validation. For that, because actually we will use almost the same code I am talking about the pre-process and the training. We'll use almost the same code provided by Monai, but we will do some changes. For example, I will not use the word validation. I will use testing, etc., etc. But we'll go to this. We'll back to go to this later. But now, as I told you, when you will download the data, you will find all these patients. But as I told you, I will not do the process for all the patients because it will take time and memory, and I have already this data. So what I did, I just took two patients here, of course, the images with the labels. So what you need to do is just to follow me how I will do this process for two patients, and after that I will show you how you can do it for more. You will know how to do it for all your patients. But there is something that I need to tell you about. Is here in Monai you will see that they are using something, because when you want to train your data or your images here in medical imaging, there are two ways to do it, because we have images with 512 by 512. I am talking about the width and the height, and the number of slices it differs. Sometimes you will find 20, sometimes you will find 50, sometimes you will find 500. It differs from your task and your data set. Okay, so in that case we cannot use directly the data, because we need to create the same dimensions of each input, so that we'll not get the model confused. So when we will fix the width and height for 512 by 512, and for example slices by 100, so we need to get all the patients or all the inputs with this same dimensions. For that, when you see in Monai's tutorials, you will find that they are doing some crops so that they can get the same dimensions. But that method works for some cases, but it doesn't work for others. And I tested that method in this liver segmentation, and it doesn't give a good result. Okay, for that I will not use it, but I will show you just a little bit, explain to you how they are using that and why I will not use it, and how can we prepare our data to use my way. It is not my way, but what I found better than Monai's way. So the method used by Monai or Monai tutorials, they take, for example, this is a patient. I am showing you only one slice, but imagine with me you have a number of slices here, which is a volume, which is actually a nifty file. So what they do, they create some crops. They create random crops, but I am showing you like this so that you will understand. But they are doing random crops here, for example, a crop here or a crop here, which means they create a window with defined width and height and number of slices. And they take this crop that they cropped using that window, and they pass it for the training. And the same thing they take in, but they take one crop for one epoch, then in the next epoch they take another crop like this, and the other one another crop from, and they are random crops, not as I am showing you here, but just to know how does it look. So that's what they are doing in their tutorials. They take only small crops and do the training on this crop and this crop, etc., etc. For that they use 600 epochs, so that they can pass by almost all the patients or almost all the slices. But I tested this way, but it doesn't work well for me. For that I want to show you how I will do it in my way, which means we will create by ourselves this window. But what we will do, we will let the width and the height the same, or we can resize the image, but we will not crop it like this, or we will not take only small parts from the image, but we will take the whole, as you can see, the whole shape or the whole content of the image. Maybe, yes, not maybe, but we will resize the images, because if we want to pass them 512 by 512 to the model, it will take forever to be trained. For that we need to resize the images. And what we can do, maybe we can crop this area so that we take only the places or only the area that has content of the image, but otherwise we will not need to take small portions as Monai are doing. So what I will recommend you, I will recommend you to not. I am recommending you, or I will show you how I will do this on my way. How to create the small patients or the small slices, groups of slices, and if you like it or if you want to try it out, I will show you everything that you do, all the scripts that we will use, etc, etc. Otherwise, if you want to use the Monai's tutorial like that, so maybe you can follow me just to understand some of the basics and some of the functions that Monai provide. But in this way, you will not use my idea, and you can skip maybe 1 hour or something like that from this video, because I will be explaining everything to do to prepare the data. Because if you will use this way, you don't need to do any preparation. Maybe there is pre-process to change the contrast, etc. But preparation, which means cleaning how many slices you have, how many groups you have, you don't need to do all that. But if you want to follow me, so you need to see how I am doing this. And after finishing the course, you can try this one, and maybe you can try Monai's tutorial or Monai's way in your data. Maybe the other way will work for you well, because it doesn't work for me, maybe it works for you. Okay, so now let's go to show you what are the preparations that we will need and how to do them. So the method that I am proposing is to create small groups, which means we will leave the same width and height for now. Before the pre-process, we will leave the same width and height of all the slide of all the patients, but we will create a constant number of slices, which means if we have, for example, a patient with 120 slices, what we will do, for example, we will create, if we will make a constant number of slices, for example, like 60 slices per group. So what does it mean? This patient of 120 slices, we will divide it into two groups. So it will be the patient 0, for example, /1. For example, this is the first part, so it will be with 60 slices, and the next part will be with another 60 slices. And the same thing for all the patients. If we fix the number as 60 slices per group or per input, that means that we will pass by all patients and divide them into groups of 60 slices. This is the idea that I found, because maybe you can, because I don't know what is your data that you are using, because if, for example, you have patients with almost the same number of slices, for example 100, 101, 102, and something like this, and all the patients have almost this range of slices, in this case you may not need to do what I will do here, because you can do in the training, you can crop your patients and fix the number of slices into 100 slices per input, which means if you have a patient with 100 slice, so this patient will go directly as an input. Or if you have a patient with 101 slices, means that you will crop only one slice, and one slice, it doesn't affect your data, because, for example, if you crop your data and maybe you will clear or 10 or 20 slices, this maybe you will lose some information of your patient. But if you just take off only one slice or two slices, it doesn't affect your training or your data. I hope that you are understanding what I am saying, because if you have almost all the patients have almost the same number of slices, so in this case you don't need any preparation of this patient. But if you have a random data set that has patients with 50 slices, another patient with 500, another patient with 300, something like that, because all the patients that all the data that you will find as public data sets, you will find them like that. So if you will find them like that, you need to follow me to clean them and make them ready for the training. So the first thing that you need to do is to convert these nifty files into DCOMs, so that you can convert or you can create small groups. Okay? To do that, for now, there is no specific Python package to do this, because I searched for that, I didn't find. I tried to create my own package to do this, and you will find it on my GitHub profile here. Like you will find amin0110 nifty to decom. So that's what I tried to create, and you will find it here. It is useful for some cases, but not for this case, because there is a problem that I couldn't find how to fix it. And if any one of you have a suggestion, please, you can leave it in the comment, or you can just take the code and make it ready for you. I will tell you what is the problem with this code, and so that you will understand. This code will take a nifty file and create your decom slices, but the problem here is that it will give all the slices or all the decom slices the same number of index. What does it mean? If you have a nifty file with 10, for example, 10 slices, so when you will convert it into decom files, it should be each slice or each decom file with different index. So for example, the first nifty file will be with the index 0, the second one with the index 1, 2, 3 until 10, which means if you want to reconstruct or rebuild the nifty file after, the Python package will understand that this first slice goes to the first nifty item of the nifty, the second one is the second cut, third, etc, etc. But the code that I am providing here will give the same index to all the patients, which means not the patient, to all the slices. So if you convert one nifty file into 10 decom slices, all these decom slices will have the index 0, for example, yes, the first index. So in that case, you cannot rebuild the nifty file again. So in our case, we need to rebuild, because we need to take groups of decoms and reconvert them into nifty files, which means it doesn't work for us. Maybe this type of conversions, if you need only to convert into decom, you don't need to or you don't need the indexes. In that case, you can use this, but otherwise for our project we cannot use it. Even if you find a way how to change the indexes, so you can take the code and change the indexes of all the decom files. Otherwise, I will show you how you can do it manually without Python code. For that, this is the parts that take a lot of time of this work, but the others are just coding and everything. I will provide you all the scripts for everything, but only this part needs to be done manually, and it will take time. Sorry about that, but it will take time. For that, I am saying, if any one of you know how to convert nifty to decom using Python or something like that, please provide it in the comments, so that anyone who is doing this project can use this package as well. Okay, thank you for now. Now I will show you the second way that you can do it, but as I told you, it will take time. We will use 3D slicer. For that, when we was installing softwares, I told you that we will use 3D slicer for some conversions. So now it is the time to talk about that. I will show you how you can do one or two. I just choose two patients here. So I will show you these two patients, how you can convert the images and the labels. And you can do this. You can see that it is easy, but it takes time. So you can do it for all the patients that you have. So now let's start by, before that, I want just to create some folders, so that we can know where to put our data, because I didn't want to make everything with Python script, because sometimes it is you can pass 10 minutes writing a script to do something, so that you can say that it is automatically, but you can create the folder in 1 minute. So just click new and create a folder. So it will take 2 or 3 seconds, but if you want to write a Python script, it will take maybe 3 minutes or more than that. So in that case, I prefer to do it manually instead of writing Python code to do it. Okay, now let's call it, for example, decom files, maybe, because what we will do in this folder, we will take these patients and convert each of them into decom slices, because nifty is group of decoms. Now let's go here. This is the decom. Let's create another folder here, one for the images. I will call it, for example, images, and then the other one we will call it if you want to do it directly with the keyboard, you can just click Ctrl Shift and N, which is new. So we will create a new folder here. So the next one we call it labels, something like that. These files or these folder names will be changed after, because we need them for our specific script. But don't worry about that, we'll come to that later. Now we have two folders, this one images and this one labels. Now let's do what I was saying to use this software 3D slicer. Let's start by the images. Let's take the first one. Just grab it here, drag and drop into your slicer, or just you can open it here. And now, okay, open it. And it will be opened here. As you can see, all the slices, you can just scroll down or just do like this. So all these are the slices. For example, this patient has, you can read here. You can see here, it is 74 slices, and you can go to other patients, you will find maybe 100 slices, etc, etc. So this is the problem, you cannot use the same script for all the patients. For that we need to prepare them with the same slices. After that we pass them to the training phase. Okay, now how to convert them? Just click here in search and click or type here decom, create a decom series. So search for create a decom series. So just go here in search, decom, create decom series. So when you click here, click 2 times here, you will get this window here. The first thing that you need to do is, there is nothing hard to do it. This is, you don't need to change this because creating a decom series, so you don't need to change that. Click here on select. You need to select the volume, or yes, the volume or the image that you want to convert. So here you can see that we have volume 0. This is the patient that we are displaying now, and this is the patient that we want to convert. So you need just to choose it here, level 0. Now you need to choose or to change the directory where you want to put your conversion. Now, as we were saying, we need to go to here to our folder that we have created called nifty files. Go here, YouTube, yes, this one, dataset, liver, and decom files. And this one is an image, not a label or segmentation. So we go to the image. Now we need to create a folder for, because if we pass here, everything will be here, every slice or all the decom files will be here, but we need to put them in one folder which is called with the same name of this patient. So we need to create a folder here, so we can call it level 0, for example, and with the same thing, or if you want to change the name here, it doesn't matter. Now choose. Now everything is set. Just click here in apply, and you will see that the conversion has been completed. Let's go here and see what's happened here. Images, we have created this, and here are all the slices. As you can see, we have 75 from 1 into 75. So everything is set, and these are all the slices, because here we see that the maximum is 74 because it starts from the index 0, so from 0 to 75, but here it is starting from 1 into 75. Okay, so there is no problem with that. But these are all the slices this is for the image 1, for the level 1. Now let's do it for the second. Just go here, and the second here we had image which is level 1, now level 0, now level 1. Open it here, and you can see now we have the level 1. And for example, this one have 122 slices, which you can see it is not as the first one. For that case, it will pose a big problem when you want to do it, or you will lose all the information of your patient if you do some crops. For that, we need to create groups with the same number of slices. Now let's select the second one, which is what we uploaded now, this one, level 1. And here we need to change the path, because we had the folder level 0, now we need level 1, something like that. And that's it. Choose and apply. So now we have the two patients have been have been converted here. Let's go images. This is the second one. Now let's do the same thing with the labels. Let's go here. We have label training. Let's take the first one here. And as you can see, this is the labels with the same number of slices. Now let's select here. You can see because they had the same name, level 0, level 0, so they added this index so that you can know. So this is the first label for the first patient as well. Now we will not do it in images. Now we are in labels. So create a new folder, call it here level. You need to put it the same because we choose to put the level 0, so we need to put the same thing, level and 0. So that's the when we will do the training, etc. The labels with their images will be the same. Okay, now let's choose this one. Yes, here we have the same thing, choose and apply. And the same thing for the second one, which is level 1. Choose it here, change to level then 1 and choose it, apply. And now everything is set for this step. When we go here, decom files, you will find images. Here is for the first one, the second one, and the same thing for the labels. This is the first one and the second one as well. So that's what you need to do at first. But for me, I am showing you only 2 patients, but you need to do all the patients. Sorry, it will take time, but I didn't find another way to do that. Okay, so as I told you, if you have the number of slices, sorry, I am repeating the word, but just to understand, if you have the same number of slices for all the patients, or almost the same with a -1 or 1 difference between them, so in that case you don't need to do what I am doing here. But if you have a public data set, as I am saying here, as you see, I show you the first, if I show you only 2 patients, the first one has 74, the second one had 122. So in that case, you can see that there is a difference. So if we go, or if we pass by all the patients, we will see that every patient has its unique, if we can say, unique number of slices, which is a problem. For that, we need to pass by this way. Now, after doing this, what we have to do, we need to create the groups that I was talking about. Groups of decom slices, which is, we can choose any number we want. In this case, I will choose 64. I don't know why I choose this number. Maybe I found that the minimum of, because I passed by all the patients, maybe I found that the patient that has less slices was between maybe 64 or 65. For that, I choose that number. But for you, it depends to you, and you need to choose the number of slices that you want, or that is depending to your data set. So you can do the same thing as I did. You go by the patient that you have, you see the patient that has less number of slices, and you take that number so that you will not lose that patient. Because if you take number more than the minimum, which means that you will lose this patient. If you choose, for example, number of slices, unique number of slices equal 100, and you have some patients that are having number of slices 60, for example. So 60 patients, 60 slices cannot be converted into 100 slices. So you will lose this patient. For this case, I am telling you to see the patient that has the less number of slices and take that number of slices as a reference or a constant number for all the other patients. Okay. Now, for the next steps, which is doing all the conversion, creating the groups and reconvert into Nifty files, everything we'll do it using Python. So I will show you how you can do it. But before talking about, or before starting coding, I am just telling you that everything is set for now. All the code, all the scripts, all the functions are here in GitHub, which I will share with you after. You can find everything here, the pre-process, and everything is here. But we will write this code, each line by code, by ourselves. But after that, I will provide you everything here, and I will provide you the notebook, Jupyter notebook. Maybe you would like to use it, because in our case we'll use Jupyter notebook in some cases because it is easier to follow the steps. But you will find everything here in GitHub, which you will find the link in the description. So now let's start creating the groups and converting them into nifties. Now, as I was telling you that you can use Jupyter Notebook, that I will show you how you can use it. I am sure that you know how to use it, but maybe did you use it in different way? That's what I want to say. Because you can install it easily in the command window, like you go here in CMD, you can open this command window, just type pip install then Jupyter, and it will be installed and you can open it, use it, and there is no problem with that. But the problem that you may have using this Jupyter Notebook directly here is not a problem in the installation, but if you want to use a virtual environment in your project, in that case sometimes it is not easy to open or to open Jupyter Notebook inside a virtual environment, or to use Jupyter Notebook with virtual environment. So the way that I recommend you, because I always choose the easiest way, and I will show you the easiest way. If you like it, you can use it. Otherwise, you can use something else. But as I told you, Jupyter Notebook, if you install it like this, there is no problem. But when you want to use it with a virtual environment, you will have some problems. So to make it easy to do this process, what you need to do is just to go install Anaconda Navigator. So Anaconda Navigator is, as you can see, it is a software that has multiple, I will show you, multiple softwares here that you can use, and which is the best thing here, that you can create your virtual environments using Conda, not a virtual environment with Python, because there is Python VMs, which is Python virtual environment, and there is Conda virtual environment. And when you use Anaconda, you can create your Conda virtual environments. You can create them using command windows like this here. Click here, Conda install, and or Conda create you, and you create your virtual environment exactly with a specific Python version and all the things that you want to set. But if you are beginner with programming, maybe it will be easy to create your virtual environment manually using the GUI here, Anaconda GUI. So to do that, you just come here. I will show you first how to install it, which is very easy. You can just go here to anaconda.com/product/individual. I will leave the link in the description, not worry about that. So when you install your Anaconda here, and you download it here, and you follow all the steps as we have installed everything else, because I have it already, so that I cannot reinstall it again. But just download it because it is free. Download it, open it, and follow the steps. And of course, you need to choose which operating system. For me, I am using Windows, so it is already Windows here. If you have Mac or something else, so just you need to click here and search for your operating system. Now, after installing it, just open it as here. You can, when you install it, it will be something like this. Now, here, if you open here this list, you will see all the virtual environment that you have in your PC, that you have created in your PC. They will be shown here, and this is the base. When you will create or you will install Anaconda, you will find only these two virtual environment. This is the base, which is the base virtual environment of your PC. This one, Miniconda, we can say that it is an example, but you will not need it because we will install our virtual environment for our project. This is testing. I just installed it again. But now, how to create a virtual environment in Anaconda? As I told you, you can do it using the command window here, CMD, and you can use the command line and install and create a virtual environment, then activate it, etc. But the easiest way here, since we are using the GUI already, you can go here, environments, and you can see, as I told you, all the environment that you have here. Now, to create new virtual environments, there is here these buttons: create a new, clone, import, backup, remove, if you want to remove one of these virtual environments. So as we said, we want to create one. So click on create. Now choose the name of your virtual environment. Let's call it, for example, liver segmentation. So this virtual environment will be the virtual environment that we will use in our project, and I will talk about that after. But now when you use it, check here in Python. Then here you can choose any Python version that have been installed in your PC. And just for me, I have Python 2.7, 3.5.6. I have everything here. So I will just choose 3.8. You can choose any version you want, but I am going to choose 3.8. And I recommend you to do this because sometimes when using Monai, if you go with latest versions, maybe you will find some problems. So 3.7, 3.8 is enough for this project. So I will choose 3.8, then here create. And you will see that the virtual environment will be created in milliseconds, not milliseconds, but in a few seconds. And now we just have to wait. And this is our virtual environment. And now here you can see the files or the packages or libraries that have been installed already with the virtual environment. As you can see, we have pip, we have Python, of course, SQLite, etc. But we will not use these because we will need other packages like NumPy, Monai, etc. But everything we need to install it by ourselves. So to install packages, there is multiple ways to do it. We can use conda install, we can use pip install, or we can just come here. We have here, when we are checking here, only we are seeing only the installed packages. If we click here, not installed, updatable, etc., or we can click just in all, we will get all the Python packages that have been that are available in Anaconda, and search for anything here, then click install. But when we are talking about installing packages, I don't prefer this way. I prefer using pip. For that, I will not follow this way. I will show you how we can use pip to install different packages. So now what we need, click create a virtual environment. Now when you are selecting it here, means that you are activating, because if you have already used virtual environments, it can be virtual environment, normal Python virtual environment, or a more conda in virtual environment. When you did it, you have always to create it, then activate it. When you write virtual environment / scripts / activate, or source virtual / bin / activate. But when you use the GUI here, when you select it here, means that it is activated. You don't need to do something else to activate your virtual environment. Now, as I was saying, we will need to use Jupyter Notebook. So here, as you can see, there is Jupyter Notebook, there is everything, VS Code, there is PyCharm, there is everything here. We can install it. We will install this because we need this after. But for now, what we need is just to use Jupyter Notebook. So you click here, even if you didn't install it before in your life, don't worry about it. It will be installed when you click here. It will be installed in your virtual environment, which means that you can use it there. So now let's click in install, and it will install Jupyter Notebook in this virtual environment. Now it is installed, as you can see, and this is the best thing when using Anaconda Navigator, because you don't need to think about how to link your virtual environment with Jupyter Notebook or something like that. You don't need to care about that. The only thing that you need to do is select or create the virtual environment, select it, then come here, and now it is already installed. So you don't need to install it every time. Now you install only one time in your new virtual environment. Now click in launch. It will be launched, and we will say here now Jupyter Notebook is working, and now Jupyter Notebook is open with inside your virtual environment. So you don't need to think or care about which virtual environment you have or anything else. Now all what you need to do is to create your folder, to check or to make a directory where you want to put your stuff or your project, and inside that folder you create a new notebook. Now for me, I selected this, so I will work on this repository, which is liver segmentation, here where we will put everything or all the code, not the data is somewhere else, but here we will put only the code. Now to create a new notebook, just come here, click on new. As you can see, there is Python tree, there is text file, folder, terminal, but for us we want to create Jupyter notebook for Python. So Python 3 IPY kernel. So IPY means that Jupyter notebook and kernel. Now what we will do here, we have, this is our notebook. Just you can click here to rename it. I will give it for example prepare, because we will use this notebook for now to do the preparation, because we were talking now few minutes ago, we said that we need to convert our images. Here we had this labels and images, they are decom. Now we need to create groups, or yes, create groups with a number of slices, then reconvert these groups into Nifty files. So that's what we will do in this notebook. Now, to do the creation of the groups of 64 slices, this was my choice. If you want something else, you can change it. Now, these are my two paths. This is the input and this is the output path. The output path, we need to talk about it here. I have because we had this decom files when we had images and labels. This is the input path, file decom files, and we have images and labels. We'll start by labels, for example. Then the output part, I have created this folder called decom groups. So you need to create a folder, you can call it anything you want, so that we will take these labels from this that we will convert, or because we will not convert actually, sorry, we'll create groups of 64 slices. So what will happen now, we will create for each group we'll create a folder, but we will not do it manually. All what we need to do is create this group where we will save all the patients or all the groups, which I call decom groups, but we will write the script that will create folder for each group, which is 64 slices, so that we can, after that, we can convert this 64 slice into one Nifty file. But before that, what we need to do is to create this decom groups, which will be a folder. Now there is something else that we need to talk about, because we have this decom groups, but what we need to do, we need to create another folder, one for the labels, one for the images. I am sorry, I know that I am doing a lot of things manually, but I didn't want to do everything using Python scripts, because in sometimes you can do something wrong and everything went wrong. Because imagine with me, if you mix only one patient, which I mean, if you put wrong one label, means that everything will go wrong, because in segmentation you need to be very precise. It is not like any other thing, it's not like any other task of computer vision. So you need to be precise, because if you will skip only one slice or only one segmentation, everything may be wrong. Okay, for that I am doing much things manually, so that I will not make these things wrong. There are some stuff that need to be done using Python scripts, but for these I prefer to do it manually. Now, as I told you, I need to create a folder for labels and another folder for the images. So we just click here, as I told you, Control Shift and N for a new folder. I will call it labels, the first one, and the second one for the images, like this. So now here I need to add labels. Okay, so the input path is our labels when we have, because for me I am using only 2 patients, as I told you, but for you have all the patients in your labels, because here decom files I have only 2 patients, but for you have 130 if you use the same datasets, or I don't know, but you have all the labels that you have here. And the output path is what we have created now, decom groups and labels. Now here where we will save our groups of decoms. Now to do this, just run this one. So to run it, just click, you can click in run, or you can click on shift enter. Shift enter, it will run this cell. Now to do this project, we need to install some, not projects, but I am talking only about this part. We will need some packages. So the first one is glob. So this package globe, if you have already used it, so you don't need to know what I am saying, but if you haven't used it before, so we will need it only to create some paths or to restore all the paths. For example, here I have this folder which has two patients. So the globe function or the globe library will help us to restore the whole link or the whole path so that we can open this folder and open this folder after. You will understand when we will code it. Okay, now I haven't installed it for this project, so we need to install it. To install, in if you are using directly Visual Code or you are trying to install in a terminal, just you need to click to put pip install, then the name of the package. For us it is globe, but for me, if you are using Jupyter Notebook, so you need to add this mark, okay, because if you don't add it, it will not work in Jupyter Notebook. Now if I will run this cell, it will install. There is something wrong, could not match install requirement version, no matching distribution, pip install. Sometimes you can get something wrong. We need to see about this, why it is not installing. Now after that I checked, because I don't know why I didn't notice that, but when you want to install globe, sorry about that, but we need to check everything every time, because I have installed this a long time ago. For that I didn't remember that I need to add this number 2 with the globe, but that's what we need to do, because this type of errors means that it is true that they are saying no matching distribution found for globe, but what they are saying that there is nothing, because they don't write that, but there is no something like this library, because the same thing, if I can put pip install, I don't know, 123, it will say, it will give the same error. It will not say that there is nothing called 123, but it will say that we couldn't find something matching with this version. But that means that you are putting the name of the package wrong, so you need to just because sometimes you can see the globe when you import it, you just put import globe, but when you install it, there is something else. Not all the packages, but a lot of packages have this, not problem, but you need to see exactly what is the name that you need to use when you want to install. For example, pillow, when you install it, you click pip install pillow, but when you import it, you click just pip install pil. So for that, this is the same thing. Just click here pip install globe 2, then run it. And now, as you can see, it is installed now. There is no problem. Now the second package that we need to install is shuttle, sorry, not shuttle, but because we need this package to move the files, because what we will do, we will move but we will move 64 slices to a new folder, which is a group of 64 slices, because I didn't want to just copy them, because we will lose a lot of memory doing this copy and paste, but I will move them. So I will take them from the old directory and post them into the new directory. So for that we will need this library. So pip install shuttle. I hope that you need to use the same name. Maybe there is something else, but we will see. As you can see, the same thing here. So what we need to do is just to search for it, how to install shuttle, something like this. And as you can see, when you import it, you use shuttle, but when you want to install it, there is PyTest shuttle. So you cannot just install it as I was doing. So just take the name and put it here, pip install test shuttle. Now let's see how does it work. It will take a few seconds, and now everything is good. So I will just delete this. So to delete them, just click on the cell and click 2 times on D to delete, and the same thing for this, because we have already installed them, so we don't need them there. Now we need to import them. So import globe and import shuttle, like this. But what you need to do to know is in globe function, this is the name of the package, which is globe, but the function that we will need has the same name, which is globe. So for that, when we want to use the globe, we cannot just make use globe and their function. We need to import another function or another class called globe from globe that we will use. I know that it is strange, but that's it. This is the package they created like this. So we need to write from globe import globe, because the same class are in the same package. So that's what we need, because if you take just globe, you cannot access to the packages or to the functions that we will need. So just run this. Now there is no problem with that. Now let's start coding, or let's start creating the groups. For that, the first thing that we have to do is to create a good, not a good, but a big for loop, because that for loop is the most thing that, because what we are saying, we want to pass by all the patients, because we can do it for only one patient, but we need to run the code each time for 130 patients, which is not good. So we need to create a loop that passes by all the patients. So for that, we need to create just for, and now patient, which is a lever. For me, I have only two patients, but for you have everything, but you don't need to care about that. Just for patients, and we will use the path, because you remember in the path here we have labels. After that, we'll use the images. So in labels, there are all the decom files that you have converted for now. So what we have to do for patient in, then here what we are saying in this folder, but if we do this, we will not have the because this in path will be only one path. But what we have to do, we need a list of paths. Okay, list of paths. Each path or each item of this list give us the path to one patient. Okay, for that we need to use the globe. This is the use of globe function. So we have globe, and when we put a path inside this parenthesis of the globe function, what it will do, it will return a list of all the items that it has in their in the directory, not the list like os.list, because here we are talking about list of the paths, not only the items. So this is the role of globe function. So what we have to do is in path, input path, but when you want to do this, you need to specify which extension or which type of folders you want to put in this list. So for that, we need to add something like, because always we have something or the name of the file, that's the extension, for example, NII for the Nifty. But for us, we don't have Nifties, but we have folders. Okay, for that we don't need to specify the extension, just put everything. Okay, but this is something like this. So what we are saying that in this input path slash everything, if we want to say we want to specify the extension, so we have to put everything that's the Nifty, for example. This, what does it mean? Everything which is, we don't care about the names, all the names or all the files that have the extension and II, take them. But for us, we said that we have folders, so we need to take everything inside this folder. So for patient globe in path plus this slash star means that everything inside that folder. So this will return a list of folders. Now what we have to do is to start doing the conversion. The first thing that I want to do is to return the patient name, so that we will use it after to save or to create a new folder for each group of items. Because what we will have, for example, we have a patient with 128 slices. So this patient will be divided into two groups. The first group is 64, the second one is 64. So what we have to do, we want to keep the same name of patient, for example, patient 1. In our case, we have liver 0, liver 1. So we will keep the same name, liver 0. But we need to add a underscore, for example, then 1 and 2, 3, etc., which is the subgroups. So you have the patient 0 underscore 1, liver, then patient 1, underscore 2, then patient I don't know, patient 2 underscore 1, etc, etc, etc. So you will know always that this group of 64 belongs to this, to the patient 1 or patient 2, etc, but it is a subgroup of that patient. Okay, I know that I am talking a lot, but I am just trying to explain everything here. So as I told you, I need to return the name of that patient. Before that, we have to add another library that we'll use. So import OS. And you should know that in each time you add something in that cell, you need to run it again, because if we don't run it, this OS will not be imported. Okay, so now after that we did this, what we have to do, we have to return the patient's name. So I will call it, for example, patient's name. So as we said, this loop will take the first patient, we will return its name. To return its name, there is a function in the OS library. So os.path.base name. Okay, this one will return the base name, which is the name of our patients, which when we say this base name means that we have all this path, this is the base name. The last item of the path is the base name, and that's what we need, because now we have label. So this globe will do slash then the first patient. So when we return the first, I will show you something. Let me just click here below. Now let me do, for example, patient list equal globe, then in path plus this. So this, as we said, this is the this list of patients will have, for us we have only 2 patients. So now if I want to print, for example, print the first item of the list, which should be the path to the first patient. So we have patient list, then as we said, the first item of the list, so 0, the index 0. Now you can see that we will have the input path here plus the lever, which is the first patient. So that's what I was saying. If I will put here 1, it will give us the lever 1, which is the second patient, etc, etc. Now we don't need this, so I will delete it. Now you understand what will be this patient in the first iteration. I forget here in. So you know that now in the first iteration we will have the first patient, which is the path of the patient, so label slash lever 0. So what we will do, we'll return that lever 0, only the name, which will be a string. We will use it after. For that, what we have to do now, inside the parentheses, we need to normalize our path in case we have any problem or something like this. So os.path.norm path, which is normalizing the path, and put here the name of the patient, which is this one, or not the name but the path of the patient. So this function will normalize the path if there is anything wrong with that. Then this function will return the name or the last item of the path, which will be the name of the patient, and it will be here. We will need it after to create a folder and to save the groups in our case. Now after doing this, what we have to do, we need to specify or to know how many folders we have or how many groups we will divide our patient. So if you have a patient with 128, for example, slice, it will be divided into 2. So we need to create 2 folders, each folder for number of for the first 64 and second one. Same thing. If we have more than that, we have to create more than that, more folders, etc, etc. So before, we need to know how many folders we need for this first patient, for example. So to do this, we have just create number of folders. Then what we need to do is to int, because why I am putting int, because we need an integer number. Because if you have, for example, 130, you divide it by 64, it will be a float number, but we cannot create a float number of folders. We need an integer. So we need to put everything inside the function int, so that it will convert the final division into into an integer. Okay. Now what we have to do, we have because what we need to do, we have a globe of the patient that we have, which is this one. This one is the globe of the patient. This will return how many patients we have, but now we need to know how many slices we have in that specific patient. So we need to create another globe, which will be something like this globe, but now we are not talking about the in part, which is the input part. Now we are talking about the part of that specific patient. So globe of patient plus slash yes slash forward slash then star, which means everything. We can here specify everything that's decom, but we don't need to do that because we know that we don't have JPEG images or something like that in our folders. So everything inside the part of the patient, which are, or everything is decom. So the globe will return a list of all that it will return a list of all that patients, not patients but slices, decom slices. Now what we have to do, we need to know how many which will be part, but we need to know how many patients we have, how many slices we have. To do that, we need to calculate the length of this list, because as I said, globe will return a list of parts of each slice. Now we need to take this one here and calculate the length of this list, which will be list of parts. I will just Control X. So length, the same thing here. So we will calculate the length. So length, what will be the length? For example, if we have 100 slices, we will have 100 parts, which will be a list of 100 items. Now this is the length which will return 100, because we said we have 100. Now we need to divide it by the number of slices that we want to create, which is 64 in our case. So divided by 64 here. So when we divide by 64 means that we will know how many folders we want. For that we are putting here integers. Okay, this 64 we can leave it 64, not 65. We can leave it 64, or we can create a variable, for example, that takes the number 64, then we use it. But we don't care about that, we will put it 64. But because as I told you, I will give you the code at the end of this course, and everything will be clean, and all these for loops, etc., will be inside functions that you can just call them, and I will show you how you can clone the GitHub repository, etc. But at the end, for now I am just explaining how does it look, how does it work, in case you have problems, in case something differs from your project to my project. In that case, you can know how to fix these problems. Okay, otherwise you can just use the final part of this course using GitHub, clone the repository, and no problem with that. Now, as I was saying, this number of folders, we needed to know how many folders we need to create. So, or how, and not or, and I am saying, and in how many groups we need to divide our patients. Now, after having this number of slices, what we need to do, we need to move the slices from the specific folder, which is here. For example, here we have all these slices. What we need to do, we need to take 64 from them and move them into a folder that we will create, which will be a subfolder or sub-patient of level 0. So now let's start doing that loop. So it will be a for loop that goes from how many folders at first, because what we need to do, we need to create the folder first and move the patient or the slices from each patient into that folder that we have created. So what we need to do, we need to create at first the folder where we want to put the slices. For that, what we have to do, we have for e in range, for example. Now we said that we need to know how many folders we need to create. So we have number of folders. So we will pass by the number of folders. If we have 4, if this value equal to 4, which is the number of folders, will be 4. So this for loop will pass 4 times. It will create the folder. Then we will write the part where we will move the slices into that folder. But now we have to go step by step. Now we have to do that after doing this, we need to create a directory, but before that we need to specify what is the final or the path of the output, which means where we want and how do we call the folder of our output of our group. So what we will do here, we need to give a name, for example output path, for example, or output path name, something like this. What we have to do, we need just to, we will reconstruct it, because we have the output path, which is this one. This one is the final output path where we want to put everything, but we don't need to put just here. We need to create another subfolder which will have the same name of the patient, which is this one, plus a underscore and the subfolder, which will be the I here. So it will be 0, 1, 2, 3, etc. So to do it is just to put here os.path.join. This function os.path.join is something that just to join two paths. For example, I have path 1 slash path 2 comma, sorry. If I have this, so this function os.path.join, what it will do, it will do just path 1 slash path 2. That's what it will do, this function. So I don't need to worry about it. So for us, what we have the final output there, which is out path, this one, which I am putting here. Then this is the main output of the labels. Then we need to put the name of the patient, which will be here patient name. Then we need to add the underscore plus the subfolder, which is here plus, which is a string, so we don't need to think about it. We can put just plus here and it will add it to the path. So plus, and we said we have underscore, then the name of not the name but the index of that subfolder, so which will be the I here. But now I is a integer, we need to convert it into string. To do it is just to call the function str and I. So what does it mean? This, it will create something. I will run it to show you how does it look. I have here print output path name. You will see what does it look. This one, just run it. It will create this path which doesn't exist for now. For now we have this part which exists, which is this is the output here, output path. But now we added this level 0. This is the name of the first patient, and this is the underscore 0. And now here it should be underscore 1. But for our case, if we have a number of patients, sorry, I want just to see something. I think there is something wrong here, because we should have 0 and 1, not 0, 1 here, because we didn't go to the next one. Otherwise, even maybe I would just, I know why. Because here we have, for this first patient, we have 76 slices, okay? So the first patient, we will create the first, because when we divide this by 64, it will give us 1 comma something. In that case, we cannot create 1 comma something folders. We create an integer folder, which should be 1 folder. So we will take 64 first patient, but the other 10 we don't need them. And in this case, you don't worry about the 10 slices, is not a problem. Okay. So this is why we have only one patient, one subfolder. And the same thing for the second one here. We have 123. So in this case, for example, it will take the first 64 slices, but the others it will not take them. Okay, but don't worry about this. There is no problem. I am taking 64 because there is other patients that are having less than that. We can put a number less than this. For example, we can put 50 or something, but I don't think that it is a good idea, because we will lose some information. For that, in average, in my case, I took this number of slices, because here, if I will take, for example, 50, so in the first patient, I will lose more than more than when I was 64, because if I will use 50, so I will lose 25 slices here. So, and the more we go with small number of slices, more than the training will be slow, and it won't be accurate, because we will put only number of slices like 30 or 40. It will not be something very accurate. So the more slices we put, the more better we have. Because in my project, in another project where I was doing tumor segmentation, I was using a groups of 128 slices, because I had patients with much number of slices. For that, I could use 128 slices, and it was very good number. I tried more than that and less than that, but it was 128, the best one. If I put more than that, it can be good accurate, but it will take time. Talking about the training time, the training, because when we will launch the training, you will see that it will take time. So more the number of slices you take, more than the epoch will take time in each time. Okay. So for that, I don't recommend you to take a very large number and not very low number. In some cases, you will lose some slices, but it is okay. Don't worry about that. So for that, I am using 64 here. Now, you see what will happen about this name. Just what we need to do, that what this function will do, just to create this name. Now, what we have to do, because as I told you, this path doesn't exist, so we need to make it exist. So we need to create a folder with this path, so that we can save our slices in this path. So to do it, just use the OS library. So os.amka, which is make directory, and here what we need to do, of course, the output path name. So this OS library will make directory for this output path name. So we will have these two folders created. For me, I have only two, but imagine with me you have 131 or 30 patients or more than that. So this function or this loop will create folders for each group of patients. Don't worry about it. Now, after doing this, what I have to do is, now after making or after creating the folder, we need to move the images into that folder. So to do this, it is easy. Just we have for, now we have this, because this first loop will pass by all the patients, and this one will pass by all the groups or all the subfolders. Now we will pass by all the files or all the slices that we have in each patient. So what we have to do is just, we have E, because what we need to do, we need to know where or when the file is, when we are more, because I am saying that if we have something like, we need to know in which index we are, so that we can stop the loop when we pass the 64 slices. So here we have 4E, because I told you that I will need it. Then I need to refer to the file, because this E is only the index, but now I want to talk about the file, which is the decon file. So 4E and file, of course, because when we use only one variable here, we use the range, but now we are using two, which I am talking about two. The first one will take the index, and the second one will take the file. So we need to use the enumerate function. And now here what we have to put, we have only the name of the patient with the path, but before doing this we need to know always the path, the patient, sorry. But when we have if I will put only the patients, it will be just the folder. But what we need to do, we have to return the list of the patients, the same thing that we did just here. We have the globe, and because this one will globe and patient plus this star, it will return all the patients or all the slices that we have in the group or in that folder of patients. So I just need to copy this, put it here. So what we are saying now, for e and file in enumerate. So this file will have the part of each decom slice of the first patient, for example, in the first iteration. So what we need to do, we need to take it, return it, and then after that we need to move it into the new folder, or to the folder that we have created. So what we have to do now, after taking the iteration from the group, we need to move it. So to move this file, we have to use, as I told you, the function shuttle, like this. So shuttle have a function called move. This move function will move the file to the directory that we want, which is now here we have the file, and the directory or the output file will be here, the output, the folder that we have created, the output path name. So what I am saying here, we have created the file. Now we will pass by all the files or all the decom files of that specific patient and move them into that folder, which is the output name for name. But there is nothing here that stops the loop. We need something that stops the loop. So how to stop it? We need to know where the iterations of the loop are in the same number of slices that we specified, which is 64. But we need to do it before moving, because if we are already passing the 64 slices, we don't need to move other slices. So just here put, now we need to put here, if we said that the I here is the index of the slices, which is the iterations. So if I equal to the number of slices, which is in our case 64 plus 1, which is when we pass it by 1, we need to stop the loop, which is using the break function. So when we call the break, it will stop this loop, which means we will not move more slices, and it will go back here and go to the next iteration to move the new so it will go to new iteration. It will create a new subfolder and move the next 64 slices to that new subfolder, etc., etc., until finishing all the subfolders, and moves to the next patient, etc., etc. Now let's try this and see what does it do. So just put here, and you can see that now it is done. Let's see our folders. As we said, here we have liver and we have decom files, labels, and you can see that it has created the liver 0. We said that we couldn't create liver 1 because there is not enough number of slices to create it. So we have 0, and if we go, we have 65 slices. Okay, I think that I missed one, so maybe we can just leave that. This one I can just leave it on, but not a problem. 64 or 65, not a problem. But you can see here that we have created groups of 65 slices for this one and for this one and everything. And if you have more than that, I am using, for example, only two patients to show you. But if you have more than that, you will see that it will create number of folders or subfolders of each patient. So if you have a patient with 600 slices, so it will create, I don't know, 10 or less, maybe 8 or 7 subfolders. Each subfolder contains 65 number of slices. And of course, if you want to change this number of slices, just change this number, which is 64 here, just change it. I didn't make a variable for that because I told you that I am just showing you. But at the end of the course, you will get a full function that has at the input part, output part, the number of slices, and it will do everything. So that was how to create the decom groups. Now the next step is to convert these decom groups, and of course I forget to say that. Now what we did for the labels, now we need to do it for the images. So what you need to do, just to change here, instead of labels, you put images, and the same thing here, images. And if I will rerun this again, this we don't need to run it, but otherwise, now if I will run this again, it will do the same thing, but for the images. Now we have the labels. If I will go to the images, you can see that it has created folders with 65 slices. So that's what all you need to do. Put here labels, and after that you need to put images, and it will do for all your patients. After doing all this, now we will go to the next step, as I was saying, to convert this nifty group, this 65. I just need to change this because I made it wrong, so I need to put 65. Now we have 60 groups of 65 slices. We need to convert them into nifty files, so that's what we will do in the next step. Now, let's talk about how to convert the decom files that we have created, which are 65 slices, into one nifty file, which we will use for the training, etc., etc. So, to do that, there is only one function, and you can do it in one line. I am talking about only one file, nifty file. We can do it in one line, and which we have multiple files. We can create a loop to do that. Let's do it step by step with you. I didn't want to write it and start talking about it. I prefer to write these lines of code with you so that you understand each line, what we are doing with each line of code. And of course, at the end, I will provide the final code. Only in the training part, it will be a very big loop. For that, I need to write it before start explaining. But all these pre-processing parts, I will explain them like this, and I will write the code with you. And if I will make some mistakes, you will see it live with me, so that you will not do these mistakes. Okay? So to do this conversion, we will need a package called decom to nifty. So this library decom to nifty will do all the work. So if you don't already have it installed on your PC, you can install it using pip install. Here, since we are using Jupyter Notebook, so we need to add this and pip install, and then we write the name of the library or of the package. For us, I said that it is decom to nifty, something like this. So when you do it, we will run this cell. If you want to run the cell here, just click on shift enter and it will be run, and we'll wait a little bit. When you see this star here, means that this cell is running. We'll wait until, this is the only problem with Jupyter Notebook, you cannot see all the execution lines or what is happening. You can just see the final output here, and as you can see, we have successfully installed nifty to decom. So after installing it, I will just delete this by clicking on the cell and click 2 times on the 2 times, and it will delete the cell. Now let's import it here. What we have to do, just we click import decom to nifty, and we will run the cell because we will need these two libraries, OS operating system, just to create the paths, and this decom file, or yes, and this decom just we needed to do the conversion. So the thing that you need to know is, when we will use this library, we will need only one function called decom series to nifty. There is another function, but I don't recommend you to use it because it will not give you the access to make it or to rename your files, which means if you have only one nifty file that you want to create, you can use that function. And in that case, I don't remember the name of this function, but I think it is decom to nifty, but I think it will convert repository, but I don't recommend you to use it because, as I told you, if you have only one patient, it is okay, but if you have multiple patients, you will not have the access to change the name or to specify the name of each patient. So in that case, if you have 10 patients, it will use the same name for all the patients. In that case, you will see only the final patient. For that case, you need to use the decom series to nifty. So this function will has 2 parameters. The first one is the path of the folder where you have your nifties, and the second parameter is the path where you have where you want to save your nifties, plus of course the name of your file. Now let's talk about our data here. We have code decom to nifties. I don't remember what I put it. It is here, lever. then decom files. And when we did decom files, we created the decom groups. We have the images and the labels here. So the images, and as I told you, I am using only 2 patients because I don't want to waste time running all these codes, because I have already created and prepared all the data. So I am using only 2 so that you can see. But don't worry about that, because the loops that I am creating will pass by all the patients. So if you have 2, it will convert 2. If you have 10, it will convert 10. If you have 100, it will convert 100. So don't worry about that. So as I told you, we have 2 paths we need to convert for the images and for the labels. To do it, what we have to do is just to take the path here. So this path is the common path, which there is the images and there is the labels. We will need it. Let's write it just here. So I will write, for example, in path, something like this, and let's just save it. And I recommend you to use the forward slashes, because sometimes the backward slash make problems. Not, for example, here, but if you have slash R or slash T or slash N, it will make a problem. So I recommend you to use these slashes, forward slash. So now this path is the path where there is the images and the labels. Now let's start by converting the images. And you can see that in the folder of images there is 2 folders. This folder contains 65 slices and the second one as well. Now what we have to do, we will start by the images, for example. Let's put here, to make it easy, we can just use the OS, but to make it easy here, let's make images. So this part is for the images. Let's make here images. The same thing for the labels. Something like this, and the folder called, I don't know, labels with S, something like this. So now we have the part of the input images and the input labels. And remember that in each part of these there are all the patients, or which are all the folders that having group of slices of each patient, as like this here. Now what we need to do, we need to return a list that has part of this file or this folder and part of this folder, etc, etc. So if you remember, we used this type of groups of returning all the group of all the files or all the folders from a specific folder using this kind of functions, because we said that globe, when we put globe and we put a path inside that globe function and we add this forward slash then star, means that this globe function will return a list of paths of all the files inside that folder. So for us, for example, we have this part of images. So the globe function of this path will return a list of 2 files or 2 items. The first item is the folder of this file, and the second item will be a folder of this file, like this. So that's what we'll do. So to make it easy, what we can do, we can just add the globe here. But before that, we need to add the forward slash star, means that everything that is in that folder, which is images, and here the same thing, everything in the labels. Now as I told you, I need to return, because here now we are writing the paths and the paths, so preferably we will not write it at the same line, but you get it. You can write everything in one line, but I don't want to do it, so that just maybe some of you are not familiar with Python. So preferably I will write everything in each thing in specific lines, so that you understand how did we go from this step to the next step, etc, etc. Okay, so here we can create a new variable called list of images, something like this. And as I told you, we could do it in the first line, but I just want you to see how we will use this part to create the list and how we will use the list to create the nifty files. Now here, as I told you, we have globe. And in the globe function, what we will do, we'll put only the path, for example, now in images. So this one here, if I will run this code, if I will put here list images, if I will run this one, as you can see, as I told you, we have two paths. The first one is for the first patient and the second one is for the second. And here we have images. And the same thing for the labels. If we create list labels, then here we have globe, and in path, I don't know why I can't type labels. Okay, now if we do the same thing here, I will just put labels, and now as you can see, the same thing, we have first patient, second patient, but here we have labels. Now these two lists contains the folders of each of the patients of each for the images and for the labels. Now after doing this, we need, I will delete this. Now what we need to do is just to convert each folder. So the function, I will just write it here. The function is decom to nifty, as I told you, the same name of the library. Now what we have to do is just to write the name of the function that we will use. And as I told you, the function is decom series to nifty. So when we are using a library, we want to call a function, you can just write decom, then series, then to, then the nifty. Very easy. Decom series to nifty. Very easy function. If you are using Visual Studio Code, maybe the editor will suggest it for you, but as you can see, it is easy. Decom series to nifty. This is the name of the function. If it doesn't exist, you will get an error, but just try to search for it. But this is the name, decom series to nifty. As I told you, there are two parameters. The first parameter is when we put the input folder, the folder that contains all the nifty files. And the second parameter will contain the path where you want to save your nifty file, and where and what is the name of your output, which is nifty file. So the first thing, as we said, is the input path. Here we have this list which contains two paths, and these two paths are the input paths that we need. So if we take, for example, list images, and we put something like 0, means that we are talking about the first path. If we want to talk about the second one, we will put 1. If you have 100, you put 100 or 99, because it starts from 0. So 99 means the final or the last patient that you have in your 500 patients. So that means that these indexes will change the patient that we want to convert. And in our case, we said that I have 2, but I will not just put 0 and then put 1, because it is not general. For that, I want to write a general code for everyone. If you have 2, 3, 4, 5, any number of patients you have, it will work for you. I am talking about the code. For that, we need to pass this function, because this function will do everything. All what we need to do is to create a loop that will pass by all the patients. So for that case, what I will do, I will just write here for patient, for example, in, then we said that in what? In all the files that we have, or all the patients that we have. And the patient that we have the same thing. For me, I have 2, but we have 2 folders. We have images and labels. Let's start by images, then we will go to the labels. So the paths that we have are here, list images. This first list contains the paths of the images. Then here we will put the same thing, the columns, and just make space. Now this function, this for loop, will pass by my 2 patients. For you, you have more than that, so it will do it for you. Now, before doing that, we need to create the output files, or the output paths. Okay. To do it, what we need to do, we can just do it manually, or you can write a code. I prefer doing it manually, because so that you will know where you are saving your files. So for me, I will start by creating a new folder here. I will give it the name, for example, Nifty files. So now we will have the exact final Nifty files in this folder. Now let's go and create two folders, one for the images and one for the labels. So let's start by images, and the next one is for labels. Okay, now I will take just this part, then we will add images and labels. We can write it here. So out path images, something like this. And now let's do the thing. I know that I am writing everything here, like maybe we don't need to write everything here. We can make a script that create the folder and does everything. But as I told you, maybe some of you are not familiar with Python, so I prefer to use this so you will understand why I am doing this. And maybe if you are trying this code, because that happens to me when you are trying to use a code of someone else, and you will get an error in your code and you will not understand where this error comes from, because it wasn't you who write the code, and you don't know what are the steps and how can you fix your error, etc, etc. For that case, I am trying to write it with you, so if you use it doesn't work for your task, you will know how to change something, how to change the folders or how to change the files, etc, etc. For that I am taking time for that, but sorry about this, because I didn't like the old way, which is just writing the code and give it to you, because I don't prefer it. Okay, now as we said, we have images, and the same thing for the labels. I will just copy this and paste it. Here we have labels, and the same thing here, labels. Okay, now after doing this, what we have to do, I will just rerun this because we need to save these files in the system. Now, as I told you, we have to pass by all the patients. But before doing this, as I told you, here we have two paths or two parameters. The first one will take the input folder, the second one will take the output folder. So for the input folder, as we said, we have paths that are in this list. So here we have patients. So because in each iteration, this variable patient will take one path from the list. So if you have one, it will be the only one. If you have two, it will turn 2 times the first part and the second part. If you have 10 paths or 10 patients, it will run 10 times, etc, etc. For that case, the first thing here, we will put only the path of this patient. Then the next parameter, on that argument, will take the output path plus the name of your patient. So the output path here, because we are talking about the images, so the output path here is the image. So we can use something like os.path.join. Why I am using this? So that we can join the output path plus the name of your patient. So in this case, the output path here for the images is out path then images. This is the output path of the images. Then the name of your patient, we need to return it. We can just make the I here from the index and make patient 0, 1, 2, 3, etc. But maybe in some time, because here there is something we need to talk about. Here, for example, not liver indigo groups. Imagine with me you have maybe 10 or 100 patients, and for example, for the first patient, you have 2 groups. So you have liver 0, 0, liver 0, 1, liver 0, 2, 3, etc. So something like this. And at the end, you want to know which patients exact, because you have created maybe 3 or 4 groups, but all of these groups belongs to the same patient. So maybe at the end, you want to know which patient had that problem. And I will not say maybe, because you need it. You should know. Because when you want to say that this patient, for example, if you are doing tumor segmentation, you need to know which patient has tumor. So, because if you just create groups and rename them, you will not know at the end which patient has tumor. For that, when you create these groups, you need to know at the end which patient For that, you need to save the name of the patient plus the index. For that case, here when we will do the conversion, we will not change the name. We will just extract as we did here. You remember here? Not this one. Remember this line, what we did here? Just we return the name of the patient. And we will do the same thing. We will return the name of the patient and use it in the saving here. So I will just copy this and paste it in my for loop. And now I have the patient is the same because we are using the same. This is very good thing when you do unique stuff. So you in each, if you will write 200 lines of code, you will remember the name of variables, because if you put multiple and or random names of variables, you will get problems at the end of your coding, because in some case, maybe you are coding now, after 1 month you want to read your code, you will not understand what this variable is doing, because all of us had that problem, that calling your variables a equal, and it will work, but as I told you, after 1 month, if you will read your code, you will not understand why did you put that. For that, I am putting in images, in path images, out path images, labels, etc, etc. So now here we have the output path. We need to join it with the name of the patient, which is here patient name. And that's it. Patient name, but there is something else. Patient name will be only the name of the folder, which will be liver here, for example, liver 0-0 underscore 0, not dash, sorry. So but we need the extension because this is the name of the patient. So if we have images, we need to put .jpeg, .png, .tiff, etc. And for our case, we need to put the extension of our files, which are nifties. For that case, we need to add the extension, which is a string, of course. So .nii. If you put just .nii, it will create a nifty file, but it will not be compressed. If you need to compress, you need to compress it after. But you can just add .gz. If you do it like this, it will convert the decoms into nifties and compress them at the same time. So if you don't need the compressed files, you can put just .nii. But if you need them converted, so you need to put .gz. Something like this. So now this loop, it will convert all the patients or all the images or the patients, but their images or their volumes. Then we will do the same thing for the labels. So just let's run this, and you can see that we have star here saying that this cell is running. So it will not take a lot of time, so don't worry about that. Let's just wait. So that's it. Now let's go to our nifty files, images, and these are our two files that we have created. Let's try to open one of them. We have 3D slicer, just to make sure that the files that we have created are good. Let's try it. It will open in any second now. So let's take, for example, the first one, drag it here, and you can see that we have only the maximum here is 64, which starts from 0 into 64, which are 65 slices. So these are the slices that we have created, and this is the good point, because you will have unique number of slices for all the patients. So in this case, in the training, you will not have any problem with your data. So now we are making sure that the function is great, correct, everything is good. Let's do the same thing for the labels. Here, just change the name into labels, and the same thing for the path. Let's go here, labels, and rerun it again, and it will convert the labels or create labels. You see that sometimes it takes few times. When I say few times, few seconds, I am saying not few minutes or something like this, because it is converting, then compressing the file. For that, it takes few, maybe 10 to 15 seconds. But it is working. Now these are two other files these are the labels, the files of the labels, and these are for the images. And as I told you, don't worry about the number, because here this for loop, it will pass by all your patients. So if you have 10, it will convert 10. If you have more, it will convert more. If you have less, it will convert less. So that was how to convert the decon files. In the next step, we'll talk about, because all these things that I am talking about are when you have data already segmented or already labeled. But maybe let's suppose that you have patients, but you don't have their labels. So for that case, I will show you how you can do the segmentation by yourself using ETK-snap. Now let me show you how you can segment your data, if you segment or label your data. So if you don't have segmentations, because if you have already downloaded data from the net, in that case you will find the labels. But maybe as we were saying at the beginning of the course, maybe the data that you will download doesn't have the same extension. So in that case, I don't know, or maybe they are using another task. For example, they are doing liver tumor segmentation, but you want to use that data for only liver segmentation, not the tumor liver segmentation. For that case, maybe you need to correct or to relabel your data. So for this purpose, I am showing you how you can do it yourself. For that, I am using ETK-snap that I shown you how you can download it and install it. Now let's start by, I will just make this window bigger. I will take this here. Now let's go to the liver. I am not a doctor, but I am sure that this is the liver. Okay, so now let's do some segmentation. I will show you how you can segment some slices, but you will get the point, because you can do the same thing with 3D slicer, but I found that 3D slicer is a little bit complicated in terms of segmentation. But ETK-snap is the easiest software ever to do this kind of stuff. It is old, but it is very easy. For that, I prefer to use it for segmentation. For example, I will show you how you can create a new segmentation, and I will show you how you can correct the segmentation. Even so, if you have already some segmentation and you need to just modify it or correct it, not to redo it again. So I will show you how you can do it. Let's create one, save it, and load it to change it after. Now, to do the segmentation, you just need to go here. You have clear label. We'll use it after. Try to choose one label. So for us, we have only one thing or one organ that we want to segment, which is the liver. So we'll use label 1. If you have multiple organs that you want to create, so you start by, for example, label 1, means that you will do, or you will segment the first organ. Then if you want to segment the second organ, you choose the label 2. So it will give 2 different values to each label and 2 different colors, etc. But for us, we are segmenting only one organ, which is the liver. So let's choose the first one, which will be in red. Now let's choose our brush. So click on this one here, paint brush, like this, and you choose the shape. The shape, it can be square or circle, something like this, or something randomly here. I prefer to use this, and this thing here, just bar here, just to control the size of your brush, something like this. And you can use these. For sometimes I used to use this 3D check box here, but what does it mean? Because I will show you with the 3D and without the 3D. When you do without the 3D, if you segment this slice, means that you have segmented only this slice. If you go to the next one, you will not see any segmentation. But using the 3D, it will segment 2 or 3 slices at the same time, depending to if the slices are similar or not. I don't prefer to use the 3D while doing the segmentation, but I use it most of the time. I use it when I want to correct my segmentation. In that case, I prefer to use the 3D or to delete the segmentation so that it will be fast. But when doing the segmentation or doing the labels, I prefer to use the 2D, normal 2D. I segment each slice by itself. So let's show you how to do it for one slice, and you will get the point for all the slices. Now just select, as I told you here, the shape, and everything is good. first label the shape here and the size of that brush here, and let's start just clicking and labeling like this as you are painting. I am not a good painter, but let's try to do it. Try to make your segmentations as tight as possible and try to cover only the lever so that the code will not get confused with the other organs, because you see that it is in grayscale and everything is similar. So if you don't segment very well, the model will start segmenting everything in the body. Wow, not too bad. It is too bad actually, but we'll correct it. Let's make it bigger here so that it will be fast. Oof, we did it. Now let's go to the next slice. To go to the next slice, just scroll something like this, and you see that for this first slice is segmented, the next one is not segmented. So you do the same thing here, just like this. I will just do it to have time, because it will take time if I will start painting. So the same thing for the other ones, just like this. And don't do the same thing that I am doing, because I am just showing you, but all these things need to be corrected. That I will show you how to correct that, but as you can see, don't do it. That's it. The same thing for all the slices. Okay, so now let's save one segmentation, and we will reload it to do the correction, for example this part or something, so that you will understand how to correct your segmentation. Now to save it, go here in segmentations and save segmentation image, and that's it. Just give the name and it will be saved at the same path where you have your images. Otherwise, if you want to change the path, just click in browse and change the path. Let me give it the name, for example test segmentation, something like this, and it will be saved with the same part of my image, which is this one. Now let's just close all these images without saving. We just closed everything. Now let's try to reload our segmentation that we have created. Now this is the segmentation that we have saved. Drag and drop here. But here, when you do it, just click on load as segmentation. Otherwise, you can go in segmentation, open segmentation, and choose the path. But if you have already the folder, just drag it and drop it here, and click in load as segmentation. Okay, and it will be opened. Put this one here. I'm going in the wrong side. So these are the slices that we have segmented. Now I will show you how you can correct these segmentations. For example, let's try this one. So let's correct this part here, and you will get the point, and you will see that it is very easy. Remember, when we wanted to segment this part, we clicked on segmentation or label 1. If we want to segment something else, we click on label 2, and it will get the green color, and it will segment another organ. Now we want to clear segmentation, or we need to delete or edit segmentation. For that case, we click on clear segmentation. That's easy. Click in the brush, check the size, check the shape and the size, for example. And now if I will go here, click, you can see that it is deleting the segmentation like this. It is clearing, and if I will do this, it will do the same thing. So now you get the point how to do the segmentation, how to clear the segmentation, and how to save it. Now when doing this, if I want to save it again, I will just click here, save. You can just click here in save it with the same name. If you want to save another file, so because here if you click here, it will pass this new segmentation in the last one, so we will lose the first segmentation. But if you want to save it as a new segmentation, just click in save as, and That's it. So that was how to do the segmentation. Now you get the point. If you don't have already the segmentations with your data, you can do the labeling using this ETK snap software. After doing this, you can pass by the way that we talked about before, which is converting into groups, and after that converting into nifties. Because I told you why we needed to do this, because if your data has the same number of slices for all the patients, or something similar like 100, 110, 120, 90, something like this, maybe you don't need even to do this type of conversion, because 100 or 90 or 110 is nothing. You can just resize them and put them at the same at the minimum, which is 90 slices, and put all your patients at that 90 slices. But if you have patients with ones or with 90, others with 200, so if you do a resize, you will lose more than 100 slices for some patients. For this case, I recommend you to create the groups of specific number of slices, as we did before, 65, and it's up to you. You can choose any number of slices you want. So that was for this. In the next part, we will start doing the pre-processing, because this part is the preparation of the data. You see that we are just preparing the data. In the next part, we will start doing the pre-process, which will be before the training. We'll do the pre-process, after that we will do the training. So let's do the next part in the next few minutes. So before going to the pre-process, there is something that I forgot to talk about, which is the images or the groups that we have created. There is something here. I will go here, datasets, lever, then the nifty files, these. So for example, this is for the images that we have created, and this is for the labels. So there is something, in some cases, when you, for example, you have a patient with 600 slices, or this is not strange because you will find datasets that have patients with 600, 800 and more than that. So don't be confused about that, but this is not the point. What I am saying or trying to say is, maybe in this 600 slices, only 100 or 200 slices that are useful. Or maybe if you have patient with 300 slices, only 100 or 150 slices are useful. The others are not useful. So when you create groups of 65 slices, you will find some sub-patients, which are the groups that we have created. For example, this one contain nothing, which means that the labels are empty, which means that part of the body that you subtracted doesn't have anything, which means all the labels are empty. For that case, these type of groups or these type of sub-patients will cause a problem with the accuracy of your program or of your model. Sorry. For that case, preferably you need to take or to delete these parts, because they are useful. Because in your 65 patients, you will have some empty slices. But if you calculate the difference between the empty slices and the full slices, you will find something like the same, or there is not a big difference. But when you take a sub patient, which will be one input, so it will be one input without any label. So imagine with me that you are doing a program of classification between cat and dog, and you put with your data, you put images of rabbits or something like this in the training. So the program will be confused. We will say that this image of rabbit is not useful. I will not use it, need it for the classification. So why you are putting it in the input? So I hope that you get the point. For that case, when you create, and this is something good when you create small groups, for that case you will delete all the parts that you don't need. So for that case, when you create the groups, you need to find or to specify which are the slices that are empty, or the groups or sub-patterns that are empty, so that you can delete them. For that, I wrote a script for you. It contains only 2 or 3 lines of code, so don't worry about it, which is useful just to show you which are the files or the patterns that doesn't have any label or any segmentation for the 65 slices. So to do it, we will do it step by step. Just we need to import one library. I don't remember if, I think we have already installed Nibabel. Let's try to import it and see. There is no problem. So we need this. If you don't have it, just write pip something like this, pip install Nibabel and run it. For me it is already installed, so requirement already satisfied. I will delete it. So after importing it, rerun this cell, so this file, this library will be imported. Now let's use it. So this Nibabel is a function just to handle the nifty files, because what we will do, we will load each file, which is the nifty file, then we will see the values of the pixels. If there is values between 0, if there is values of 0, 1, 2 and something like this, more than only one value, means that this sub patient contains labels. Indeed, it contains the 0 values for the background and the 1 for the foreground, and if you have multiple objects, you will have 2, 3, etc, etc. And and if you will find there is only zeros, means that this part contains only the background, which means there is no organ, there is no liver in that part, so you need to delete it. Okay, this is my recommendation. If you don't want to use it, you want to use all your patients, you are free to do it, but I don't recommend you to use multiple groups or sub patients which doesn't contain anything in that case, because when you put the patients directly with random or with random slices having labels or not at the same time, there is no problem. But when you put one input without any label, so this is the problem. So when you create the groups, you need to make sure that you don't have any empty labels or any empty patients. When I say empty, which means there is no part that doesn't contain label. Okay, so let's start coding this. As I told you, the first thing that we need to do is to open the image, which will be, for example, I will call it image or nifty file. So to do it, we will use the Nibabel. I just need to use this. I can use the shortcut like as nib. It is a convention, they are always, but you can use directly Nibabel, but it is convention to use nib as for Nibabel to make it short. So nib, then that's the function load. This function load will load one patient. So let's do it for one patient to show you how does it work. Then we'll create the loop that will pass by all the patients. Now let's do it. Let's start by taking this path, for example. Here this is the output path, but for us we need it as an input here because we need this path. But you don't need to use the path or the files of the images, because the images, we are sure that images have multiple values, have zeros, 1 and something between them. But for the medical images, you will find values between -3000 or -1000 into +1000. Don't worry about that. This is the medical imaging. Welcome to the club. So what you have to do is using the labels, because we said that we need to see if there is label, if there is foreground in that part of the body. So for that we need just to check the labels, because the labels will specify the foreground and the background. We cannot see that in the images. So let's take the path of this output images, which will be our input here. So I will just put input nifty file path, for example, and that's it. Control V. So this is the all path. For now we'll take, as I said, we'll take only one patient. So I will just take the name here. After trying with one patient, I will show you how. We will just add a loop that will pass by all the patients. Don't forget to add the gz, because the files here are compressed. So .gz. Now what we will do, just we will load this patient, which will be here, input something like this, input nifty file path. So if we run this cell, there is no error, no problem, because we just loaded the image. It is here in nifty file. What we need to do now, there is something in the in medical imaging, if you have already some knowledge about that, there is not only the image exactly, which is the array of the image. We are talking about the nifties or the decoms, the same thing. There are other informations like the patient information, the name and age, etc. There are value, or there are informations about the pixels, the dimensions of pixels, etc. We will use this in the pre-processing. Sorry, we'll talk about them later on. But for now, what we need to do, we need just to extract the value, the matrix or the array that contains images, which are the slices. Because what we need to do, just to take this values or this matrix that has all the values of the slices and verify the slices of each patient where there is only zeros or where there is 0 and 1 or 2 or something like that. For that, to subtract or to extract the array from the image, which is nifty image, there is a function called getFdata. Fdata means that frame data. So we can just create, as I told you, we can do everything in one line, but I am just writing each thing in one specific line so that you can understand the steps that we are passing by. So here we have fdata, which means frame data. To do it, just write the name of your patient, which is nifty file dot get f data. It is a function, so we need to add the parentheses. So this f data will contain the values of all the slices. So it will be an array of 65 slices, because we have passage of 65, and each 65 slices or 65 items, and each item is an array of an image which contains the values. So we need to know if these values contains only zeros or zeros and 1 or 0, 1, 2, 3, etc. For that case, we need to specify the dimensions of this fdata. But using only dimensions will not be the thing that we need, because dimensions will just give you how many slices or something like that. But there is a function in NumPy called unique, numpy.unique. So this function unique will return if there is or if there are unique values. So if you have only zeros in your function, if in your array, so the unique values will be only 0. If you have 0, 1, 2, 3, but you have multiple 1, 2, 3s in your image, so it will return only the unique values that you have in your image. So for us, if the unique values will be only zeros, means that this image or this patient contain only 0. That means that there is no lever, so we need to delete it. If this unique function returns 0 and 1 or more than one value, means that in that case there is something in the image. There is the background and there is the foreground indeed. So to do it here, what we can do, as I told you, we can choose the number, the function unique. So here what we can do, just I will create another function, sorry about that, but as I told you, I want to write everything. So I will call it numpy unique, and now we can, I don't remember if I have numpy here, we don't have it. So if you don't have numpy, just as I told you, just something like this, pip install numpy, and it will be installed. But for me, I already have it, I think. So I will put import numpy as np, something like this. So it is already imported. Now let's use it. So np dot unique, and here we will put the array that we have, and for us we have f data. This is our unique our array. So let's print this. So np, while using Jupyter Notebook, you don't need to use the print function. You can just write the name of the of your variable and run it. It will just print it here like this, as you can see. And for us you can see that we have 0, 1, 2. For us, we have more than one value. We don't have only 0. Means that there is the background and there is the foreground. For that case, we don't need to delete this patient. If we have only 0 here, we don't have this 1 and 2, we have only 0, means that we have only the background, so this patient need to be deleted. I hope that you get it. This is the point, that's all what we need. So the function that we need to do is only to specify the length of this return or of this unique NumPy array. So what we can do, we can just say if np unique, but as we said, we need the length of this variable. So length, if the length of this np unique is bigger than 2, which means the length is not 1. If there is bigger than 2, means that we don't need to delete that patient. But if this length is equal to 1, means that this patient need to be deleted. So if equal to 1, let's make just like print, and let's print this patient. So for us, we'll print this part because we are having only one, but we'll do it for a loop. Now let's print it here. There is nothing printed because this patient has foreground and background. So if you are in the case where there is no foreground and background, you have only the background, so it will be printed. Now let's do it for all the patients. You have a database for with I don't know 100 patients. Let's do it now. So let's say that labels, and just put here star. This means that this path contains multiple files. So this star will return everything inside that folder. To do it, let's start by creating the list as we did here. We need to create a list of labels, and it is equal to globe, then here the path input path file, nifty file. Then here this list of group of paths will be used in the for loop as we did before. So now let's just write for patient in list labels. Then let's do what we have done here. We can just copy these and use them. There is no problem. Let's just pass them here so they will be in the condition, if condition. Now what will be happen, but just we need to change this because we need to load that specific patient, not the folder here. So here load the patient, which is here for the loop, load the patient and get the frame data from that patient, calculate this unique, then calculate the length. If it is equal to 1, then print it, but we will need to print the patient. So here, sorry, I am patient. So we will read it, we will load it, extract the frame data, get the frame data, then choose the unique, calculate the unique values. Then if it is equal to 1, the length, then print it. Let's just run this, and you can see that there is nothing printed because both patients that I have here are with the foreground and background, so there is no problem. But if you have patients with more, because for me, even my patients that I used in this test has only 100 and the second one has 120 or 110 slices. So when I created the nifty groups, the decom groups, and converted them into nifty, which are sub patients here, they should have slices with the lever, because if I had the large number, if I had patient with 600 slices, for example, in that case I will get definitively I will get 3 or more than 3 groups of decoms or groups of 65 slices which are empty. So for that case I needed to delete them, because in this task I am showing you only 2 patients, but I have already prepared the data and I had that problem and I have deleted all of them. When we start doing the pre-process, I will show you how I created the folders for the training and for the testing, and we'll do everything together. Don't worry about that. Now, as I told you, this is the script That's verify if you have empty files. In that case, it will print them and you can delete them manually. I wanted to do it with a script to delete, but I had some problems. Sometimes if you do something wrong, you may delete the wrong files. But if you want to do it, you can just add a line to delete that patient. But I don't prefer that. I just want to print them, maybe verify them, but it's up to you. If you want to delete them, you can just add the delete or the remove function from the shantel that we used before here. This function shantel, you can use it to delete the file and just put then call the shantel, then here put the path, which is the patient of that path, of that patient, which is the empty, and it will delete it for you. So if you prefer to do this, you can do it. So now after doing, I think that now we have completed everything about the preparation of the data. Let's start doing the pre-process and of course eventually the training. So now, before doing the pre-processing, because all the functions that we will use or need to do the pre-process are included in Monai and PyTorch. So before doing that, we need to install Monai and PyTorch and all the dependencies that we will need at the beginning. Maybe in the process we will need some other libraries, but they are not the most important ones. But the important ones are for now Monai and PyTorch, because we will use them for the pre-process, for the training, for the testing, etc. For that we need to install them. But before doing that, we need to install CUDA and cuDNN, which are the packages for the GPU and the toolkits for the GPU, so that we can do the training using the GPU, not CPU. Because using the GPU and my training, sometimes it took 2 days, 2 days to be completed, because the images are very big. So imagine with me if you have 60 or 100 patients, and each patient contains 300 slices, and these 300 slices we will divide them, but I am talking about at the start. So for example, if each patient will be divided into 2 or 3 parts, so multiply your 100 patients by 3, so it will be 300 sub-patients, and each sub-patient contains 65 maybe slices. So imagine with me how large your data will be. And we will use the 3D Monai, so we will do 3D convolutions. So it will take time. It will be very slow. For that, you need to be careful, not careful, but you need to be aware about that. You will prepare your data, verify it. If everything going well, just run it and leave it for 1 day or 2 days. Depends to how many patients you have. For me, I remember one time the training took me 2 days or 2 days or a half. When I say 2 days, means that 48 hours, not only 2 days, just like that. So I have a GPU with GTX 1080, but it wasn't that fast. So you need to be aware about that, because maybe you will say that I can use Colab, because Monai, they are using Colab in their tutorials. But remember that the images or the data that they are using in their tutorials are patients with small number of slices, and they have only 40 patients maybe, I think. And for that, the training doesn't take much time. But if you have dataset with large number of patients and with large number of slices, be aware that it will take time, especially if you will run it in your PC. Because even if you want to run it in Colab, I think that you know that in Colab you cannot run more than 12 hours. If you have a good internet connection without any cut or something like that, it cannot go more than one run. It cannot go more than 12 hours. So you can pay for Colab Pro, so you will get 24 hours. But as I told you, sometimes it took 2 days. So be aware about that. Okay, and don't be scared if the training took 2 days, because I am just telling you that it can do that. Okay, depends on how many patients you have. So to do the installations, the first thing, as I told you, we need to install the CUDA. You can just go to their website, developers.nvidia.com/CUDA downloads. Otherwise, you can just write in Google here, CUDA download, something like this, and go to this first link and you will get CUDA Toolkit 11 if you have problems, because if we are using TensorFlow, it may be a problem, because TensorFlow with some versions of CUDA or cuDNN, if you don't download or if you don't install the some specific versions, you will get problems at the end. But with PyTorch, don't worry about that, because I will show you when we will install PyTorch, you will see everything clearly. So don't worry about the versions. If you want to install 11, you can install it. If you want to install 10, you can install it with no problems. So here we want to, I have already these cuDNN and CUDA installed in my PC, so I will not download them again, but I will show you how to do that. Then we'll go to the installation part. So for me, I am using Windows. If you are using Linux, you can just click in Linux. So I will click Windows, this x86. Then here the version of Windows, I have Windows 10. Then you want to use it in network or local. I prefer use it in local. And now everything is set. You can just click on download and something I will just click to show you. And you can choose the directory where you put your file, and it will be downloaded successfully without any problem. And after downloading this, you just go here. I have them here. Open your, I will not do it again as I told you because I already have it, but I will show you. When you click on it, you will get the window. Let's wait. My PC is a little bit slow these days. I don't know why, but let's see. So click on run, then choose the directory. I will not click because if I will click, it will start doing the installation. So everything is easy. Just click in next, 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 and everything will be installed. After installing the CUDA, now let's go to cuDNN. cuDNN is another package which will be used with CUDA. So just go here in developers.nvidia.com/cuDNN, or just you can go here and press download, press download cuDNN. Okay, so here NVIDIA cuDNN, the same thing, and let's go on download cuDNN. And now to do it, you need to have an account, and it is free. Don't worry about that. You need to have an account, developer account. So once you create an account, you can just choose version. It depends to you. So for us, we have downloaded CUDA 11. So we need to install this. If you have already another version of CUDA, so you need to check the version that you need for your CUDA. So click on archive or cuDNN archive. So you just find all these versions. So see which CUDA you have installed in your PC and install the available or the corresponding cuDNN version. After downloading it, what we will do, I will show you how to do it. It will be something like compressed file. When you decompress it, you will find this file, folders. So that's what you will find. So to install cuDNN, very easy. You just need to copy and paste these cuDNN files into CUDA where you have CUDA installed. So if you want to see where your CUDA is installed, what you need to do, just go to your PC and go here in your desk, then your program files, and you will find the folder here, NVIDIA GPU Computing Toolkit. So this folder will be created automatically when you install CUDA, sorry. And if you go here, you have CUDA and you have the version. If you have multiple versions, you will find multiple versions here. But for me, I have only one, so you will find this one. Now, I will just keep this here. I will open another one. We have the recordings here, downloads, and cuDNN. So as I was saying, what you need to do, just to copy the files from the bin of the cuDNN, paste them into bin of CUDA, and includes of cuDNN, just copy them and paste them in includes of CUDA. The same thing for the lib. Copy these, go to lib, x64, copy them and go to lib here and x64 and paste them here. I have them already, so I will not do it again, but you get the point because I have cuDN and all the files are here. So just select all, copy them and paste them here. That's all what you need to do. And the last thing that you need to do is to go to your system environment and add your file, the parts of the lib. I will just show you here. Properties, advanced parameters, variable systems, variable environment. And now if you go in parts, you will find that I have, I don't know if I can, yes, I can move it here. Now for me, I have these parts, the part to the bin, to the bin to the bin NVVP, and the other one which is extra qpt slash lib64. Where you will find them, they are all here, CUDA version. So this is the first part, which is the bin. So go to bin, copy this part, copy it, Ctrl C, and come here, click in new and paste it, and that's it. Click enter. The same thing for the other one, which is the lib NVVP, this one, and copy it, create a new part, paste it, and the same thing for the extra, copy TT lib64 and copy this and paste it here, and everything is set. Now you have installed the, I will just close these. Now you have installed your cuDNN. We'll go to this one here. We have installed cuDNN. Now we need to install Monai and PyTorch. Let's start by Monai, the easiest one. To install Monai, you can just do pip or conda install. So here, pip install Monai. That's it. It may take some few seconds. It depends to your internet connection, and because my internet connection is very bad, so it will take maybe 1 minute or less. Let's stop it for a few seconds, and now you can see that it is installed. Now let's try to install PyTorch. So to install PyTorch, we need to go to their website, pytorch.org. Okay, that's it. And now to download it, because when you go to pytorch.org, you will go to this page. Just scroll down here, check the stable version. For me, I am using Windows. If you have Mac or Linux, you can just select them. After that, I want to install them using pip install. If you want to use it, what will differentiate when you click in CUDA, it will be CUDA install instead of pip install, but you can see that some things will be different. But when you use, for me, I am using pip install, so it will download the packages from the website, PyTorch website. Okay, so pip, then Python, because we are using Python. Now if you have CUDA 11, check CUDA 11. If you have CUDA 10, check CUDA 10. If you don't have GPU and you want to do your training in CPU, I don't recommend you because it will take 1 week. So you need to check on CPU. So it will be pip install torch vision torch audio. For us, we have CUDA 11 because we installed CUDA 11.5, but don't worry about that. 11.3 does the work because we don't have 10, so we have the 11. Then copy these lines and we will install them. So for us, we are using Jupyter Notebook. I need to do it. So here you can see that pip3, you can leave it pip3 or you can make just pip. Where we have pip3, because if we have installed pip2, Python 2 and Python 3 in the same virtual environment, so in that case we preferably need to use pip without number, means we are talking about Python 2. If we put pip3, means that we want to install that package in the Python 3. For us, we have only Python 3, we don't have Python 2, so pip, it will install in the Python 3. So when we run this cell, the same thing, this installation may take some time, depends to your internet connection. So after doing this, everything is set and we will start doing the pre-processing after installing Monai. As you can see, Monai is installed, and CUDA installed, Cudiana installed, and now we are waiting for PyTorch. Let's stay for a few seconds to see this message successfully installed. Yes, we have to see it. So now everything is set, and you can see that PyTorch is installed without any problem. Now everything is set, we don't need anything to install for now. I will delete this and this. If I will click, for example, import Monai, it will be imported without any problem. So now you can see that everything is set, because I started with this because I told you, because we will need Monai and PyTorch for the pre-process, even for the pre-process, not only for the training. For that I needed to start by this installation. So let's start doing the pre-process. Now let us talk a little bit about how to do the pre-process. So I will not go to the steps, each line of code by line, because I have already done videos and blog posts about everything that we need to do for the pre-process. So you can find the links here in my website. There is in my PyCAD.co. You will find a blog post about pre-processing in detail, and also the YouTube video about that. So you can check it out, so that I will not repeat everything in each video, because I know that if I will talk about that, it will take a lot of time, because only the video about pre-process I have two parts, each part for 40 minutes or 50 minutes. So imagine with me if I will talk about the pre-process and the data augmentation, that we will come to it later. So it will take a lot of time doing that, but there are already videos that I have done about that, and there are blog posts that you can read, there are code, etc. But don't worry about the code, because the code that we will use here is more I have just ordered it, and it is well done, because here it is, you will find the code, but it is only for the pre-process. But here, since we are going to do the training after the pre-process, so I have created some functions instead of just scripts doing the pre-process. I have created functions that you will find in my in my GitHub repository. Don't worry about that. At the end of this course, I will be talking about everything. So I will show you how you can just git clone this GitHub repository, and how you can call all the functions, because you will find that every function that we will use is here. For example, how to calculate the dice matrix, calculate weights, everything we will talk about it later. Here is the function that will do the training, because as you know, in PyTorch there is no a specific function as in, because if you have used TensorFlow before, you will find that there is that function .fit, model.fit, so it will launch the training, and it is a little bit easier. But in PyTorch there is no function called .fit, so you need to write the loop by yourself. And almost all these things in the training part, I took them from PyTorch, from Monai tutorial, but I just have done some changes to make the code clear. But we will come back to this later. And here in the pre-process, we will find all the functions that we talked about for the creating the groups and nifty to decom and find the empty. And at the end, we have this function prepare, which contains the lines of code to do the pre-process. So everything is here in GitHub, but I will make it clear at the end of this course, and I will show you how you can just clone the repository, use the functions. But before that, I just wanted to explain to you some of these parts, because as I told you, I will not go to everything line by line, because you will find the explanation here. But just to give you a small explanation, I will talk a little bit about some of the not the functions, but only some transforms that we used here. Because if you go in Monai's website, you will find that there are tons of transforms that you can apply in your data for the pre-process and for the data augmentation. But for us, I will not use all these data, all these transforms, sorry. I just took smaller, few of them just to make the data clear, but I didn't do like a huge things for the data because it will take time and it will take memory, and I don't have that great GPU to do all these functions. But I will show you how it will look using only these pre-processings, and you can do it yourself like this. If you want to add more functions, of course it will be great because you will see the results at the end. They will be acceptable, but if you train your model for more data than I am using, or if you do more pre-process or more data augmentation, of course your model will be improved better than mine. But we'll go to this later. Now let's talk a little bit about the pre-process. As I told you, here as you can see, I have created 4 variables. Each variable contains the path for the training volumes, training segmentation, then the testing volumes and testing segmentation. If you have already seen the tutorials of Monai in their website, you will find that they are not talking about testing, they are talking about validation. But I prefer to call it testing because when we see validation in deep learning, most of the time means that these data will be used in the training and it can affect the model during the training. But here, of course, we will, because if you see the tutorials of Monai, you will see that they are using actually this data that they are calling them validation data. They are using them during the training, but they are not affecting the training. For that, they stay always testing data because we just use them to see what happened, but we don't use the result of that validation data to do some changes in the model. For that, I prefer calling them testing data and not validation data. But it's up to you, you can call them anything you want, but I don't prefer to call them validation. And if you want to leave it a validation, you can do that. So as you can see here, there are some important things that you need to keep in mind. The first thing is the name of your folders. I am not saying that you need to call your folders with the same names that I am doing, but what you need to do, or what is important here, is that you need to specify the name, the exact name of your folders, because here there is the first thing in your path or where you will find your data. The first thing is the main path, which means the directory where you have all the folders or all the patients. For example, here for me this is the whole, or this is the main folder, which contains four folders. I will just minimize this. And this directory contains 4 folders. The first one is the test segmentation, where you will find the masks for the testing, and the second one is the test volumes, and this one training segmentation and training volumes. Volumes means the patients, and segmentation here means the labels. Okay, so these are the 4 folders that you will need. So if you are calling them the same as I am calling them here, you can just leave the code. Otherwise, if you change these names, then you need to change these names as well here. So if you will go with me at the end and just fork the GitHub repository and use it, for that case, you need to change your folder's name to make it easy. Or otherwise, you can change in the code, but maybe the best thing, if you are using the same code, the best thing is to change only the names and not all the not the code. Okay. And the second thing, actually I will talk about this later on, and I will show you some examples, but now I will give you just small words about that. You need to be specified about this thing here, which is the extension of your files. As I told you, we cannot use something like other types but Nifty, so we need to use Nifty files. But the second thing here, as I told you here, when we add .gz, means that this Nifty file is compressed. So if your files are not compressed, you need to delete this .gz, because if you leave this .gz but your files are not compressed, means that this not this. This is just defining, this line is just defining the path. But here, when you will load your data and you don't put the exact extension here, means that the function nibabel that will open this volume will not find this file. It will find, for example, patient1.nii, but it will not find that .gz. In that case, it will not recognize that it is the same patient. For that case, it will not open it, and you will lose this patient. And imagine with me, if all your patient doesn't have this .gz, means that your code or your program or your function will not open any type of data, and it will not open your patients. In that case, you will find your data loader here empty, like there is no data, and you can do nothing with that. And the problem here is that you will not know. This is the biggest problem with Monai. You will not know where is the problem. It will not give you an error here. If you will run this code, there is no error. But when you will try to not print, or you can, if you want to print, or if you want to upload your images, in that case, you will find that your data loader is empty. And you will not know that the problem is with the extension. This is what I am saying. You will mess to delete this extension, but the code will not tell you that you have messed something, or there is something wrong, or the directory is wrong, or there is no such a directory like this. Because always when we do, or when we put the wrong path, always we get the error saying that this directory doesn't exist. And in that case, we will know what is the problem. But with Monai, you will not know that. You will find just the data loader is empty, but you will not know that it is empty because you just forgot to delete or to add this .gz. The same thing for other stuff, but as I told you, I will show you that in practical, but not for now. Now I am just explaining, but after that I will give you a small things that will cause problems, and I spend a lot of time trying to debug that, because you will not know where is the problem. You need to print everything in your code so that you may find the problem. For that case, I will show you some of the problems that I found during my PhD, but during my master thesis while I was doing this project. Not this project, but something similar. But in this case, maybe if you will find, or if you will be faced with these problems, you will know how to solve them. So, as I told you, there is four variables. Each variable represents the path for the volume segmentation for the training, volume segmentation for the testing. The second thing here is to create two dictionaries. The first one is for the training, second one is for the testing. Dictionaries is only some rows and columns, and these are the keywords, and these may cause a problem as well, but I will not talk about them now. So this one is vol for volume, this seg for segmentation. So these are two keywords. Each one represents a column. So this column is for volumes, this column is for segmentation. And in each column you will find some rows, and each row contains the path for each patient. So the first, for example, first row, first column will represent the path to the volume of the first patient. The first row and the second column will represent the segmentation of the first patient, etc., etc. These for the training, and the same thing for the testing. And you will find all the explanation about these in my blog post and in my YouTube video about that. So I am just giving you a small recapitulation, but you will find everything there. And now let's talk about this transform function. This transform function, you can see that there is this function compose, which is, you can find this in PyTorch and Monai. They are using the same thing here. Compose is a function that allows you to use or to apply multiple transforms at the same time, not to apply a first transform to the image and the output image pass it to the second image, that the second function that will do the second transform, etc, etc. But using this compose function, you don't need to worry about that. You just need to define which are the transforms that you want to apply, and it will do that by itself. You don't need to specify which one, the first, the second, but here it will take this order. This one will be applied the first, this one second, etc, etc, until this last. And about that, some of these functions need to be in the exact order, but others doesn't matter. You can add them anywhere you want. So the first one that need to be at the exact order, which is this one, which is load image. Load image, because before doing any transform, you need to load the image first. So to load the image, you need to use this load image D. D is for dictionary, because you can use Monai with these dictionaries, or you can use them just with opening images without using these dictionaries. So when you do that without dictionaries, you need to delete this D. But if you are following my code, or if you see the code doing by Monai, they are always using dictionaries, because it facilitates everything in the code. Because if you use just script with all the paths, it will be something painful. But here you know that when you use the keyword vol, meaning you are talking about volumes, here segmentation, because you will find that everywhere when we talk about how to show images or how to train images, everywhere we'll use these keywords. So it is something that will help you and not be painful for you. So I recommend you to use this way, which is the dictionaries. But if you prefer the other way, of course you can use it, and you need to delete this D at the end of all the functions. Okay. So after loading the function, the patient, sorry, you need to add a channel, because as I told you, in our case, there are two, for us, for now, there are only two channels for the output. There is the first channel that represents the pixel for pixels, or the mask for the background, and the second channel will represent the mask for the foreground. In that case, you need to add a channel here so that you will have two channels. Okay, but you will add another one to specify the batch size, but it will be added here from the data loader. Don't worry about that. And of course, as I told you, you will find everything here explained in this blog post. Okay, now after adding a channel, there is something that you need to do, which is changing the pixels, the pixel dimensions of your patient. This is as well one of the important things that you need to keep in mind, because what you will do here, I am using pixdim and pixdim here because I am using this pixdim in the parameters or in the arguments of my functions that I have created. And you can see that I am putting here 1.5 for the width, 1.5 for the height, and 1.0 for the depth of the pixel. So in your case, you will find maybe because the problem here with the public dataset, you will find some patients having 2 by 2 by 2, others 0.5 by 0.5 by 0.5, others 1 by 1 by 1, and if you use them as they are, you will cause a problem. For that case, you need to put them at the same dimensions. Okay, for that case, you need to use this function, which is spacing, which will change the spacing and put all the dimensions the same. And the problem that I told you here, you will find a problem here with the depth, especially because with the width and height, if you define just a constant number here, it will fix the problem. But with the depth, it will cause a problem if you don't choose the right value here. I am using 1 because I found that with data there is no problem with the value 1, but in others it may cause problem. We'll come back to this later when we will talk about all the problems that you can face during using Monai and deep learning for medical imaging. Now, The next thing, I will not talk about this because it's not that important, but here, for example, this one, scale intensity range, this is another important function which will change the intensity values or the intensity range of your images. Because if you print the maximum and the minimum value of your pixels, you will find that it is from, not all of them, but some of them vary from minus 3000 into plus 3000, others from minus 1500 into plus 1500. They are huge values. For that case, you can never do a training with these values. You need to put them from 0 to 1. Okay, you need to normalize them. But before doing that, you need to change the contrast, because if you don't do any changing of the contrast and leave them as they are, there is no visibility to the images. For that case, if you will do a training or something like that, you cannot recognize the different areas or the different organs from the image. For that, you need to change the contrast of your image. For that, here I am using, because this b mean and b max are from what you will normalize, the values will be from 0 to 1, but this a mean and a max will represent the values that will change the contrast of your patients. Let me give you an example, because for me now as you can see here, I am putting a mean equal a mean, a max equal a max, because these are the arguments that I will pass in this function. For by default, I am putting them minus 200 into 200, but when I will call this prepare, I can change them. Otherwise, if I don't specify them, it will take these values by default. Okay, I put this because I found that these values are the most in average. This is the important. This is the best ones in the average, but not all the time. But how did I find these values? Now I will show you a simple trick that you can use to find these values for your specific data. So let's open here ETK Snap, and let me wait. Let's choose one of, let's open this patient, for example. Now, as you can see, the visibility is little bit, we can say, normal. We can see the different parts of the body. So here we can see the liver with no problem. But why? Because I am changing the contrast. If I will not change the contrast, I will go here to tools. You need to click in tools, then image contrast, then contrast adjustments. You will get this window. If I will click in reset, this is the exact, or this is the values that you can find. As you can see here, for example, the minimum is minus 1000, the maximum is 1400 for byte, or I don't know what is the unit for this pixels, but the value of that pixel, there are some pixels that they are having the maximum value, which is 140 for 1400, and others having minus 1000, etc, etc. In that case, the visibility is not that easy. For us, we are doing liver segmentation. Maybe we can see it, but it is not clear. Imagine with me, if you are trying to detect something like, I don't know, this one or something, you cannot recognize it because everything has the same color for now. So to do that, you need to change it, and you can use these arrows and try to find something visible. But when I tried this, it wasn't that great, but I tried just changing values here randomly, and for that, when I found these and here where I found the values, not this, sorry, I found here where you need to change. You can change here values, and these are the minus 200 and the plus 200. If you want to do some changes, you can just adjust these values, but you can see that the best thing is minus 200 and plus 200. Okay, and if I will change here, you can see that the values here are changing. Okay, but if you need, if you want to use this, for example, this parameter, and as you can see here, this one is better than minus 200. Okay, so we can just take this in consideration, but you don't need to use everything that you can see. Maybe for my data it is working well, but for other data maybe it will not work very well for that. Okay, so you can do a training with this. Otherwise you can just do any changes here. For example, I don't know, 100, and here for 500 or something. And when you see that the image or the organ that you want to detect is visible, you can just take these minimum and maximum, and this minimum and maximum are the values where you will put here a minimum and a maximum that will be placed in the scale intensity range, and it will be here for a minimum and a maximum. Okay, the next function or the next transform is this one, crop foreground. Sorry, this crop foreground is one of the, I will not say the important, because if you don't use it there is no problem, but it is one of the useful functions or the useful transforms, because here you can see that this is the whole image, because it is the black area, but I will just reset here to make it clear, but you can see that it is a black area, but it exists in the image. For that case, preferably you need to delete all these borders that you don't need and just take this foreground part. For that case, this function crop foreground is useful for that. It will do that because you can see that in each function we do here, when we want to specify that transform for the volumes, we call the keyword volume. When we want to do it for the segmentation, we do segmentation. When we want for both, we write both of them. And you can see that most of the time we apply it for every keyword, which is for the volume and segmentation, because we want to load volume segmentation, add channel to the volume and segmentation, change the spacing for the volume segmentation, etc, etc. But here for the spacing, for example, we need to do it only in volumes, because our segmentations are values from 0, not from 0, but values of 0 and 1. So if you do these changes, you will lose all your masks, because they are binary masks, so you don't need to change the segmentations. For that we write here only volumes. And now, as I told you, here there is, say, the second keyword or second argument, which is source key. Because if you use the source key like segmentation here, in that case segmentation, it will be only black area, only something white in the image. So if you do that, it will crop all your image, and you will lose all the information, and you will get only the white area or the place where there is a lever in your mask, and in the slices where there is nothing in that slice, what I am saying, it will crop all the image. For that case, you need to put here source key, which is the volume. For that case, it needs to see or to look at the image, not to the mask. So it will look to the image and crop this parts and leave only the interesting parts from the image, which is the foreground. Okay, now after doing the foreground, here there is the resize transform, which will resize your images and masks as well. So that's what I am using. This here, you can find that there is spatial size. This spatial size is what I am putting here in argument. Spatial size is the new spatial size of your images, or the new dimensions. So you can see that I am putting 128 by 128 by 64. Here I can put 64 or I can put 65, because our data that we have created are 65, but I will leave it 64, there is no problem. But you know that you can put here, you need to put here the exact number of slices that you have created. So if you have created the same number as I am using here, then you can use 64. If you are using more than that, you can, but you need to change this value. Otherwise, if you didn't create the groups as I was talking about in few not minutes, maybe a few hours before this part, I talked about maybe you don't need to create the groups, because maybe you have some some numbers of slices almost the same. For that case, you just use here, or you just need to put the average number, or the minimum, not the average but the minimum number. So if you have patients with 100 slices, others with 110, others with 105. So in that case, the minimum is 100, so you need to put here 100. So all your patients will be resized into 100 slices. And for the width and the height, you can put anything you want here, but you need to be careful. You don't need to put something that will make the image not visible, and you will lose all the information of your image. And I am putting it this smaller, because if I will put it more than that, the training will be very slow and maybe will not be accurate. Not I think that if you put it 256, it will be more accurate, because I tried that in another machine, not mine, but it will be slow. Okay, but for that I don't want to put it in my machine, because it will be slow. For that I am using 128, but if you have a good machine or good GPUs, you can use this, you can increase these dimensions of your images when you do the resize. Okay. And finally, after the resize, what you can do is to change or to convert these images into tensors. So this one will open them, do all these transforms, and after doing everything, you need to convert them or to transform them into tensors. You need to be sure that this function need to be the last function that to be called, because you cannot convert them into tensors then resize them. It will be an error and you cannot even run it. For that, you need to be sure that this to tensor is the final, or yes, the last function that you need to call. Okay, so this all what we need to see. But if you go here to the Monai's documentation, you will find that they have huge number of transforms that you can apply, but I didn't want to make it complicated. I took only the necessary ones, but if you want to put more, you can put more. And now let's talk a little bit about the data augmentation. If you want to do some data augmentation, then you need to see some transforms here from the exact page, because their page of transforms here contains the transforms for preprocess and the transforms for data augmentation. So you just need to search for it. Maybe you just need to search for the word augmentation or data augmentation and find all the functions, because I used some Gaussian noise, there are some zoom, there are some flip, there are multiple transforms that you can use. And I wrote another blog post about that you can see and take an idea about that. I think I have some examples here. For example, this is the same patient with multiple transforms, and I have created all these. This one with Gaussian noise, this one shifting, this one with flipping, rotation, everything you can find in the documentation, and you can read this blog post to have an idea about that. And of course, if you need, or if you want to add some data augmentation, you need to add it in the training part, not in the testing, because in the test you don't need to do any augmentation. Augmentation have to be done in the training. So you can find, or you can search for the function, add it here, and of course before this to tensor. Okay, so that's all about the functions. And now let's talk a little bit about how to do the data loader. Data loader is just to combine between the files which we have been defined here, and the transform that we will apply to each file or to each patient. So this is all what you need to know about the data loader. It will combine the images or the files with their transforms, and it will apply the transforms and load them in your RAM, and you can use them after. But there is something here which I am putting here, cache. This cache I am putting here in the arguments. If it is false, means I will not call it, which is I am talking about this part. If it is true, I will call it here. But what does it mean, this cache function? This cache function, because you can use cache dataset, or you can just use dataset. If you use this cache dataset, after what I read and what I understand, is that this function will load your data into the GPU memory. In that case, the training will be more fast, or will be faster. And it is true, because I tried that with the cache and without the cache. With the cache is faster. When I say faster, is maybe 5 or 10 times without the cache. But although it will be slow, because even with this cache it will be slow. I don't know why, but depending to how many passings you have, what is the batch size that you are using, and what is how many epochs you want to train your model. For that case, it will control the speed of your training. But using this cache will make your training faster, but not always you can use it, because if you have a lot of data and you have a small memory in your GPU, in that case you cannot load it. And if you do it, it will start loading it, and in some point it will give you an error saying that you don't have memory in your GPU. So you can use it, or you can try to use it at the beginning. If it works, that's happy for you. If it doesn't work, just put this cache false, or you can just don't touch it here, and it is by default false, and it will do the training directly without loading any passings in your GPU memory. Okay. Now, after doing everything here, what you need to do just to call it. But for now, what we need to do, if we just call this function, we cannot see anything. We need to plot it. For that, I wrote this function for you. I didn't write it, to be honest. I found it from the Monai tutorial. I just made some changes, and I am using it as you are. So I didn't do anything by myself. I just did some changes. I just write some documentation here, because these are some problems of Monai. There is not enough documentation to understand what they are doing, and there is no raising. Well, I am saying raising because when you will have problems, you don't know what is the exact problem. You need to spend days trying to find or to figure out what is the problem. So these are two problems with Monai. If they are watching this video, I hope that, because you are having a great framework, but just you need to improve these things, and thank you for that. And now let's talk about how to show one patient, and of course you can do it for multiple patients. The same thing here. I am creating a function called show patient that will show a patient. You need to put in the parameter here, the data loader that you have in your images. So this part, as I told you, it will take the data loader, which means it will take the output or the return of this function. I did this specifically because I wanted to make it easy for you. You don't need to write the same code, the same here at the same function here, but you can just call this function and take its output and use it as an input here, and it will close your image or your patient. For that, I didn't want to use it as that. I didn't want to use it at the same function here. I just made this function for the preparation or for the pre-process, and this function for the showing one patient. So this function, as I told you, it will just take this data, which is data loader, and here we are returning the data loader for the training and for the testing. For that, I am taking here check patient train, check patient test, because this is a list of two data loaders, training and testing. And now I am doing this view train, view test, and now what I am doing here, this function called first, it is from Monai. This function first will just take the first patient from your data loader. If you have 100 patients, this one will return only one patient, so that you can plot it or you can do anything you want with it. So this first function will return this first patient. This first one will return the first patient from the testing. And now we have two patients to view them or to show them. One from the from the training, one from the testing. And that's it. I am using here if condition, one for the training and one for the testing, because if you want to see a patient from the training or you want to see a patient from testing, there is no specific thing, because if you just want to see your data after pre-process, so it doesn't matter if you see a training or testing patient. But just I like to put everything here to make it clear for you. Maybe you want to play with it. For that you can just make this true, false, or you can put them both true, so you will plot one from the training, one from the validation. No problem with that. So let's go with this here. After doing that, just you need to create your figure, and I will put here subplots. And as I told you, these parts I took them from Monai, and you can find them in Monai or otherwise, because it is something like only pure Python. Just create a figure, and before that, this matplotlib, this function or this package here, maybe you didn't have, or you don't have it in your virtual environment or in your system, so you need to install it. I don't know if I talk about this or not, but don't worry about this. At the end I will give you the requirement.txt that you can use to install everything. But if you are following the tutorials, you can just install it by pip install then matplotlib. I have it already, so I will not install it. And the same thing for this tkdm function. This library is not, if I can say, it is not one of the important things, but it is included in some parts of the code, not only my code, but even in the code of Monai's. So you need to install it, because it will just show you the progress. So if you run a for loop, for example, it will be running the progress or showing you the progress in which iteration you are, or something like that. It is useful sometimes, but for now Monai is using it, so you need to install it, otherwise you will get an error. Okay, so just delete this. And now, as I told you, after installing my matplotlib, just import it here, matplotlib as plt. And for that we are using here plt.figure to create the figure, plt.subplot to subplot our figure, to divide it into two parts, because here I want one line or one row, two columns, and plot this first part in the first deviation. So if we have window here, we divide it into two, so one row, two columns, and this is the first part where we want to plot the first patient or the first image. And for us, the first image that we want to plot is the volume of that image, which is this part, which is this volume. And the second part here, because this is the second part, will be the segmentation of that same volume. And here we specify the number of slices, not numbers, sorry, the slice number. So if you want to print the first slice, second slice, until 64 or 65 slice, which we have in my case. If you have more, you can print more. Otherwise, you can even add a for loop if you want, and plot every slice you have or every patient you have, and you get the point. This is for only one patient, one slice, and if you want to do it for more, you can just change it. Here at the arguments of my function, I am putting here, this is the required argument that you need to put the data loader, which is the output of the preparation function. Then here you can specify the number of slice number, otherwise it will take just the first one. And here if you want to print a training patient or testing patient, and that's it. That's all what you need. Now let's try to make an example about that. Let's run this cell by clicking in Shift Enter, and the same thing for this one and the last one. Now everything is set. Let's do an example. Before that, we need to return the patient. So I will just take this path I will give it in directory equal this here. Let's change this backwards slashes because sometimes it give an example an error, so I will just change them. That's it. Now after having the in directory, we need to create the patients. So for example, I will give it, it is not patients, they are patients. So we can put it patients, or I will put it only one patient because we will print only one, upload only one patient. So let's just name it patient without that s to make it complicated. So patient equal, now let's call the function prepare, which we called here, which we defined here. This is the function prepare. As I told you, the first parameter is the in directory, so we have called it the same thing, in directory. For the other parameters, you can change them, otherwise if you leave them as they are, these are the greater ones that I found in my case. If you want to change them, you can play with them and see what will happen, but for now I will not change them because they are great for my type of data. And now if we run this, there is no problem. You can see if we want to show one of the patient that we have, so just call the function show patients. I think this is the name, show patients. And now here we just need to give the patient as a parameter. The other parts we don't need to change them, so for now it is 1. If I will run this cell, it will take few seconds because it will do the data loader. After that it will show you this patient. Now let me change this name, this number of slices. I think it is the second. We can just write here, for example, 5. You can see here. Now this is the fifth slice. Let's take, for example, 20. And that's it. Let's try, for example, 40, and it will be the last one. And that's it. If you want to do more with that, you can just play with this, change the patients, change everything you want. And these are the two parts that we need to talk about before the training, because there is the pre-process and there is the second part, which is the how to show one of your patients, because we will need this function for now and we'll use it after the training to print the results or to plot the results. So that was how to do the pre-process, how to show patients. Let's talk now about how to launch the training we're using Monai and PyTorch. Now, before starting doing the training, I will talk a little bit about the common problems that you may face, because there are some problems that I found and I didn't know how to fix them because the error doesn't specify where is exactly the problem with my code. Okay, so I will show you only 3 of them which were common for me, but maybe you will find others that maybe you didn't install NumPy or something like this. These problems are very common and you can find them, but these problems with Monai, sometimes you will not find any if you go in Stack Overflow or even in Monai's repository in GitHub, you will not find answers about these errors. For that, I will just give you these 3 errors that I found, not I found, but I faced during my project. And others, maybe if you will find other problems, you may ask me in the comments, or otherwise you may find them in Google, because these 3 problems are the only problems that I didn't find solutions after a while, doing 2 or 3 days trying to debug the code. And you will see that the error is something very stupid, but you will not know that causes problem. Okay, so let me just jump to the code and show you how I will do these mistakes with you and show you how you can fix them. It is not about fixing them, because you may do everything good at the beginning and you will not face these problems, but I just wanted to talk about them separately, not in the in the code. Okay. So the first thing is when you put your input data path or the directory of your data, if you do something wrong with it, you will face a problem that I will show you here. How does it look, the error, and you may not know that the problem is with your path, because it will not tell you that you have a wrong directory or this directory doesn't exist. You will not find this. I will show you what type of error you will find, and if you will get this type of error, means that you are making or you are putting a wrong path or wrong name of your folders or pathogens or something like this. So here I am sure that this path is true, but you can do a mistake with your path, or some of the time you will not do a mistake with the path, but I will show you where you can make or when you can do a mistake, because it happened to me and it happened to a lot of people. You will get wrong name of folders, for example these ones, because I told you when I shown you the folders, I told you that if you want to use the same code, you need just to name your folders as mine. Otherwise, if you want to change them in your case, then you need to change them even here, because you will not get an error telling you that the problem is with the names of the folder, but it will not work. Okay, of course, because the path is wrong. So this the first thing, maybe you will forget an S here. You may just write train volume, you forget the S, so in that case it will not work, but it will not tell you that you are forgetting the S or you have the wrong path. The second thing, maybe you have nifty data not compressed, which means you don't need this .gz and you are putting it here. For that case, the code will search for nifty compressed files and it will not find this nifty compressed or zipped files. In that case, it will give you an error, but it will not tell you that we didn't find this file or we didn't find a compressed file. It will not tell you that. So let me just leave it like this and I will run the code and I will show you how does the error looks like. So now let's just run this cell. The same thing this cell, because I will try to show an image so that you can see, because if we run only this, you may not find the error, because you will find the error when you call this function, which is this prepare function. So when you call it, it will do the operations and it will find the error. So to call it, you can call it you doing the training, so you may face the problem during training, but for us we didn't start the training yet, so I will show you how you can face the error only when you are trying to plot one of or to show one of your patients. So I run these two cells. Now let's go to the first problem, which is this one. As I told you, everything is good here, the directory is correct, everything is correct, only this name of patients, which are everything.nii, it should be .gz, because for me all the patients are zipped, but I deleted that so that you will see how does the error looks like. Now let me run this cell. Let's wait a few seconds. So this is the error that you will find, and it is saying that there is no object or this, because in reality, what does it mean? It takes this data loader, which is the output of this function, and take the first patient from that data loader and show it. But it is saying that this data loader or this view patient is not, it is not talking about the view patient, it is talking about this check patient, which is an output, which is the data loader. It is saying that there is nothing in this list. It is like an empty list. You cannot, like doing the index 0, index 1, it is not subscriptable. So in that case, you will see that your data loader is empty, but there is nothing saying that the problem is before the data loader. It is not saying that the path is wrong or there is no file named .nii without .gz. It is not saying anything. So if you face this problem, you will not understand why your data loader is empty. You may understand that your data loader is empty, but why? Why it is empty? Because you forget this gz. That's it. Maybe you can put .g and you forget z, so this path doesn't exist. So everything related with the path will not tell you that you are having a wrong path. So in that case, you need to check your paths, check your files, etc., etc. So that was the first error that you may face. You may face this error saying that your data loader is empty. In that case, you need to verify before the data loader, which are the path here. Maybe it can be this keyword, but for the keywords I found it give you the specific error. It will tell you key errors, and it will tell you that the problem is with the key. This is a good work. But if you have problem with path, it will not tell you. So be careful with that. Now let's go to the next error, which is when you put a wrong keyword in the dictionary. So we are using here the same keyword, vol for volumes, seg for segmentations. Imagine with me if I will put here, for example, I do it wrong, I put two L's, so vol with two L's. I was writing my code very fast, I didn't see this error. So this, of course, I know you are Python developer, so this will give you an error. So it will not work, but sometimes you will not see it, because I remember one time I spent more than two hours trying to debug the code, and it was the problem was here. And I remember it wasn't even here, because here it is very easy to see it. It was inside my transforms. Maybe it was here, or I don't remember. Maybe it was here. So if you run the code, where is the second error? This one, wrong. So if I will run this code, you will get this big error, and you will get confused. What is this error? And I don't understand what is happening here. And you can see that it is showing you the arrays of your patients, etc. And you for me, I was like, what is this? What is all this writings? I didn't understand what is the problem. And the key and the problem is just here. It will give you, because for that you need to read the error carefully. This is not my case. Sometimes when I see this big error, I just stuck and I don't know what is happening here. But actually you maybe you don't need to read all of this, because you will not understand what is saying here. But if you go just a little bit here, you will see that where is it? But it is saying that the problem is with key error, and you come here to tell you that there is a missing key, which was missing, which is this volume with two L's. So in that case, you see that there is something wrong. And because if you see the last error here, because if you don't read that, you go to the last error, you will find that this is runtime applying transform. And we see what is the problem. Maybe I am, and it doesn't tell you even here which transform is wrong. So you may go to all the transforms trying to change the values. That's what I tried to do before. I changed these values of this fixed dimensions, or maybe spatial size, etc. And the problem is a little bit stupid, because just you are putting an L here wrong. And when you are stressed doing your project, you may not see this type of error. Believe me, I am saying this because it happened to me. So, but if you read the error carefully, you don't need to read all this writing, because you don't need it. But you go just here, and here it starts telling you where is the problem. And here you can understand that there is a problem with the key error. Then you just go here a little bit, and you can see that problem with these transforms. And of course, there is here a keyword telling you that the key error telling you that this keyword is wrong. And I think they may give you even the name of the transforms where there is the problem, because here it is just telling you that there is a problem with the keyword, but which transform is having the problem, I will just see which one, if it give you or not. I don't remember that. Transforms, because the problem, as you can see here, is always telling you that the problem is with the transforms. Okay, we understand that, but which transform is having this problem? I think that it gives you which transform having this problem, but I cannot see it. Compose. No, there is nothing talking about that. Keyword, dictionary. Yeah, that's it. And you can see you will spend time, because I know that it exists, and I spent few seconds searching for it. Imagine me if you don't know that there is this kind of errors, you will not find it. So you can see here runtime error applying transform, and because at the end here it is saying the same error, runtime error and applying transform, but it doesn't say which transform is which transform is having a problem. But if you go a little bit here, you can see that the problem is with the spacing the object transform. So now you have two helps or two keywords to see your problem. The first one is you have a missing key, which wrong key, which is this volume with 2L, and the second problem is this. You know that which transform is having problem, which is spacing D. And you go just a little bit here, now here, and it told you that spacing D is having a problem, and second thing is volume, and you see now, oh yeah, this is a problem, and you delete this. And the same thing if you have a problem or you have missing key or wrong key in other parts. It can be in the training or in validation or in testing, because the problem, if you have it in testing and because all the time when we try to save, not to save, but when we try to test or to show patient, all the time we use the training patient. For that I added here training or testing. If you need to, you need always to use or to test your validation or your testing data, so that you will understand. Because here when you will launch the training, because as I told you, I am using the same code of the training used by Monai. So in that case, not the same, but I made some changes. But you will see that in this case, they will use there is a part of which they are calling it validation. I am calling it testing. I told you why. So during the training, you will use some of data so that you can print or you can plot some of your validation metrics. So you will calculate the loss of your testing and the loss of your validation. The same thing for both. For them, they are not calculating the loss for the validation, but I added it so that you will get the metrics for both validation and for the not validation, for the testing and for the training. But in that case, you will not see the problem only when you will run the code. So the code will be run, the training part will run without any problem. When it comes to the testing, which is the validation, when it comes to the testing part, it will try to load one of the patients, and it will find that there is a missing problem with the path or problem with the keys or something like this, and it will stop the training, tell you there is a problem, and you will not understand. Maybe you will not even know that the problem is with the testing, only a key in the testing part. So you need to keep in mind that if you get some of these errors, maybe this one, or maybe this one, this one, right, talking about transforms or something like this, you may get only the last one here. You need to check your keywords in your dictionaries. You need to check your paths of your data. Now, after telling you about these two, there is the third one, which was one of the biggest problems that I faced in my project. When you see doing the segmentation, and of course most of the time if you do the segmentation by yourself, it is easy and you may not get this type of errors. But if you get a public dataset or someone give you the public dataset with the labels, so in that case you may face this problem, because maybe for us we are doing only liver segmentation, but maybe you will download data that have been used for liver and tumor segmentation, or liver and heart segmentation, which means for three classes. There is the background, the liver and the heart, or background, liver and tumor, etc., etc. So the data have been used for that case, but you want to use it only for background and liver only. So in that case, you need only two classes, background and foreground, which will be liver. But the data haven't been done for that case. So you need to change it. You can change it before doing any training on ATK Snap. I have shown you how can you just modify your segmentation, so you can do it manually. Otherwise, you don't need to do it, because if, for example, you have data, because if you have data for liver and tumor and liver tumor segmentation, so the tumor will be at the same part of the liver. In that case, you don't need to clean it before. I will show you only in the code, in the training part, how you can just change it there. But if the problem, or if if the error is in the for example, the data has been made to segment liver and heart, for example. So in that case, you need to delete the segmentation for the heart, because it will cause a problem. But if the same, because sometimes even for, if you have data only for liver segmentation, you may get, maybe the man or the person who was doing the segmentation, maybe he did something wrong. And in some cases, at the same area of the liver, he puts another color or another value or something like this. So if you have more than two different values, so the code will detect them as classes. So more values or more different values you have, more the code will detect different classes. And that's what happened to me, and you will get the error, and you will never understand that error is happening from that. And I wrote a blog post about that. I will just show you, but I will show you how you can do it in the code. To fix that problem, you will need to do it in the training part, not before that, because as I told you, if you have segmentations for training and for liver and heart, so in that case you need to do it before the training, and you need to delete all the segmentation for the heart. But if you have the same, you have only one segmentation but with different values, I am talking values, I am talking about the labels, because they are masks, binary mask, it should be 0 and 1. If you have multiple classes, so it should be 0, 1, 2, 3, etc. Each value represents what's one class. But for us, we are having only two classes, so we need only two values, which are 0 and 1. And in my data here, I have problems, and I will show you how, what are these problems. I will just search for the problem. Yes, this one. You will get this type of errors. This error is made from PyTorch. When you will run the code, you will get something like this, and you will not understand where is the problem. You can read this blog post to see where is the problem. And I have here an example to show you. If you have labels, for example, for me, I was doing tumor segmentation, so I had two tumors. But for my case, I didn't need to do instance segmentation, which is the first tumor, second tumor, etc. I just needed to know what is the background and which are the tumors. So they should have the same value and the same color. And here is the problem. And now I will show you how you can fix it. So as I told you, if you have two different parts of the body segmented, you need only one. So you need to delete the second one using ETK-Snap or any software you want to delete that part. Otherwise, if you have only one organ segmented but with different values, so you need to put them at unique value. So I will show you one of the patients that I have where I have this problem. So one of my patients, for example, this one, has this problem. I will just print it here to show you. So you can see that this patient here has three different values. It has 0, 1, 2. And in my code, I will tell him that I have only two classes, the background, which has value 0, and the foreground, which has values 1. So the code will find these values too. So it will detect them as a third class. But in my code, I will tell him that I have only two classes. So in that case, PyTorch will have that error, which is this one. What is it? This one, this error, you will get it, and you cannot run the code with that error. So all what you need to do is just to make a condition saying that all the values which are more different, that's what I was doing, different to 0, I will put them true, because you can use 0 and 1 or true and false because you have binary segmentation, so you don't care about that. So all what I did, the values which are from different to 0, I put them into true, and the values which are 0, I put them into false. So that's what happened. If you have multiple classes, so you need to talk about that, and you maybe if you have multiple classes everything is good, but for me I have only two classes, foreground, background, and it is detecting something else. It is giving me this kind of errors, so in that case you need to change it. Okay, so that was about the errors that you may face. Now let's start talking about the loss function that we will use, and we'll run the script to do the training. So for the loss function that we will use the dice coefficient. So the dice coefficient, which is, or we can call it dice loss, because sometimes you heard about dice coefficients and dice loss, and I wrote a blog post about that. It is few months ago, talking about what is the difference between them, and you will see that there is no difference. It is the same thing, but you can use it as a metric or you can use it as a loss function. I use it for both, but you will see that it is stupid doing that, but I just used the both because I tried to use, because even Monai, they are using dice loss for the loss function, and they are using the compute, they just function called compute dice metric, but that dice metric, the way they are calculating it, it may cause an errors for me, and maybe it may cause errors for you, where you have a lot of empty, as I can see, empty slices where there is no labels. So I understand what is the difference between them, and I try to write the not function, but it's a small equation in one line to calculate the dice coefficient from the dice loss. Actually, we need to calculate the dice loss, then we calculate the dice coefficient, then we calculate the dice loss. But Monai are providing us directly the dice loss equation, and it is working right, good. So we can go back from the dice loss into the dice coefficients. I will give you just quick explanation about that, and you will know that you can do it even yourself, okay? But of course I will provide you the code to do it. But here, the first thing that you need to do is to know is the dice. What is the dice coefficient? Because all of you, maybe if you have done segmentation before, or even you have done object detection, you know the intersection over union value or metric. So dice is not that different from the intersection over union, because the intersection over union is the intersection between the ground truth and the predicted mask divided by the union, the ground truth union the predicted mask. But the dice value or the dice coefficient is calculating the intersection here between the ground truth and the predicted mask divided by the sum and not the union. So divided by the sum, and everything you will multiply it by 2. So I will give you this just small explanation that I have already done in this blog post, so I am just reading it. Sorry about that, but you will know that these graphs are more, you will understand with these graphs more than just talking or writing. So let's suppose that we have these two circles. The first one, for example, A represents the predicted mask, and the B represents the ground truth that we have. So this is intersection, of course you know it, and this is when we say intersection over the sum multiplied by 2, means that the intersection is only this yellow part divided by the sum. We don't care about if they are the same or not, we sum them, and here we put the intersection. So what is the meaning of this case? When you have a good segmentation or good model, means that the intersection between the predicted mask and the predicted mask and the ground truth will be almost the same. So you will get only one circle here because they are supposed 1 over 1. So you have the ground truth is over the predicted mask. So in that case, the value between them is the same, and you will get only one circle, which is in yellow here, which is the intersection between them because they are the same. And in the sum, you will get the same thing because we said they are the same. So A plus B is the same thing, which we are saying 1 plus 1, 2 plus 2, etc., etc. So you will get one thing here because only one. divided by 1 plus 1, which is 2 times A or 2 times B, because they are the same. So you will get 2 times one circle, or the intersection if you want to say, and divided by 2 times the same thing. So you will get 1. So 1 is the maximum value that you can get. On the other side, if you have, for example, the intersection is not, your model is not, is very, very bad. So the predicted mask is very, it is not as your predicted mask. So when you do the intersection between them, you will get nothing. So it will be 0. So the intersection will be 0. So when the intersection is 0, divided by anything, it gives you 0. So 0 is the minimum value that you can get for the dice metric, and 1 is the maximum value that you can get. So the dice, we are saying dice metric and not dice loss. So when we say dice metric, so plus we are closer to 1, more our model is good, and more we are closer to 0 means that our model is very bad and there is no segmentation between the or there is no intersection between the predicted mask and the ground truth. And going from this case, we can now choose or find the equation of the dice laws. And the dice laws, what we know about dice laws is not dice laws, but the laws in general. The laws in general should be closer to 0. So more we are closer to 0 means that the error, because the loss is an error between the predicted mask or the predicted thing, which can be mask, class, or bounding box, and the input, which means the error between the output and the input. So more the error is slow, which means which means is closer to 0, means that your model is good, or your segmentation, classification, detection is good. Now we had only this dice value, and this dice value, we said that when it is closer to 1 is good, and we need to know, and we know that the dice loss, more it is closer to 0 is good. So what we can do is just to calculate the dice loss is 1 minus dice, which is dice coefficient that we calculated. So if this dice is good, which means is closer to 1, or we can say 1, so 1 minus 1 equal to 0. So the dice loss is 0, which means you have the minimum loss that you can get, which we will never get it, but the dice loss, this dice coefficient, maybe the maximum will be 0.999999, something like this, and 1 minus 0.99, it will be 0.0000001 or something like this. So in that case, you have a good loss, good training, and good model. So this type of those dice loss we will use in our case, in our training. There is another loss that you can use, which is binary cross entropy loss. For them in Monai, they are calling it cross entropy dice loss, and it is the same thing. I will just give you, when we start writing the code, I will just give you how you can calculate this cross entropy, because I used it and it was useful in some cases. Because when you are trying to segment, for us, we are trying to segment liver, it is something big in the image, so we don't really need this binary cross entropy. But when you are trying to do something, because I used it when I was trying to segment tumors, so the tumors are small area in the image. So in that case, where the tumor is small area, means that you will get the number of pixels of the background 1,000 times or 10,000 times the number of pixels of the foreground, which is the tumors. So in this case, you will get a problem called imbalanced data. This problem, imbalanced data, is very common in the classification, and we said that segmentation and classification are almost the same, but we are classifying each pixel, not all the image. So you may face this problem. So you need to use that binary cross entropy that will penalize the model when the error is in the class that has minimum pixel values, or minimum pixel numbers, not values. So I will just provide you after the code to do it, but we will not use it in our tutorial. We'll use only dice, normal dice coefficients, and dice and the dice loss. But if you want, in your case, maybe you want to use this binary cross entropy or cross entropy dice loss, you can use it using the code that I will provide to you. So let me talk to you a little bit about the cross entropy, the weighted cross entropy that I was talking about when I talked about the loss functions. So if you have already know what is the, because this is my master's thesis, I just wanted to show you what is the difference. So if you have the cross entropy laws that you have seen before or used before, you will see that you have this equation, which is this ground truth, the sum of the ground truth multiplied by the log of the predicted mask, which is the output, everything divided by or multiplied by -1 divided by n. So this is the normal cross entropy loss. But the weighted cross entropy, it's the same thing, but they are adding this w here, which is the weight. These weights are the things that we need to calculate, and I wrote the code for you to do it. You will find it just here in utilities. So this code will calculate the weights. These weights are nothing but probabilities. So if you have, for example, 1 million pixel of black pixels, which are the background, and you have, for example, 100,000 of pixels of the foreground, which are the levers, for example, lever, not say levers, but lever, for example. So in that case, you will calculate the probability between them. So of course you will get a probability of pixels or having pixels of background bigger than probability of pixels having foreground, which is the lever. But this thing here, when you want to calculate the weighted cross entropy, what you need to do is invert them. Use the probability of the black pixels for the error when you are having when you are calculating the dice or the weighted cross cross entropy of the foreground. So here let's give it let's talk step by step. So let's say we are calculating the cross entropy, or we can say the weighted cross entropy. So if we are calculating the errors of the background, so when the model is not predicting the background, so if you have background and the model is giving you that there is a foreground there, so which means there is a lever, but in your case you know that not you but the labels is telling that there is no background, there is no lever there, so the output should be a background, but the model is outputting a foreground, which is a lever. So in that case you need to penalize it in the back propagation. So in that case, because the model will be penalized depending to the error. So if the error is big, so the model will be penalized a lot, so it will change the weights and it will be very penalized. But if the problem is in your if the error is small, for example 0.001, so the model will not change the all the weights, maybe few of them, and it will not do a big change, because it knows that your model is accurate and it doesn't need more changes. But as you know, if the error is 0.9 or something is closer to 1, means that your model is very bad, it doesn't predicting anything, so all the weights need to be changed, and that's it, updated, what I want to say, not changed. So the idea here is, if you have an error in the background, or for us we are saying background because we know that the pixels of the background are maximum of the pixels than the pixels of the foreground, which is the lever, because most of the area of the patient doesn't have a lever, but the lever, there is a lever in specific slices, but all the other ones are empty, which are background pixels. So if you calculate the number of pixels of the background, you will find it 10 times, not 10 times, but you will find it 100 or 1000 times than the pixels in the foreground. And even for this, how to calculate the pixels, because you will need them to calculate the probability, there is a code that I write it there for you. I think utilities, show passing, yes, this one, this function, which is calculate pixels, you will give it the data, which will be the data loader, which is the output of your of the preprocess function that we created, which is prepare. So the output of that function will go to this function, and this function will calculate the number of pixels, which are the pixels of which are the pixels of the background and the foreground. So this function will output an array or a list of two values. The first one is the number of pixels of the background, and the second one is for the foreground, which are zeros and ones. Okay, so the values that will be returned from this function, you can use them here in the inputs of this. So this value 1, which will take the number of pixels of the background, and this value 2 will take the number of pixels of the foreground, which are the lever in our case. In your case, you have something else or the same thing you want to segment, but the background is the first one, the foreground is the second one. Okay, so just to make it easy, because you can inverse them, but you need to know that you inverted them, so the output of your of this function, which is the return of this function, will be returned. So you need to take care about that. But you need to, if you want to something clean, you need to write them in the same order. So your first class, which is the class with the index 0, needs to be 1 to be here. The second one is with the index 1, 2, 3, etc. If you have only 2, so 0 and 1. So this function, as I told you, it will return the probabilities, but it will be inversed. So of course we have the number of pixels for the foreground, for the background, are bigger than the background, than the foreground. So what you will do, you will use the probability of the background for the error in the foreground. So for example, let's say that the probability of the background is 0.9 and the probability of the foreground, which is the lever, is 0.1, because we need the sum of them equal to 1. So this one, the probability of the background is 0.9, the error of the foreground is 0.1. So what will happen when you are calculating your error here, which is the weighted cross entropy? When you are calculating the error of the background, you will multiply the error by 0.1. Means that your error will not be bigger. So it will be like almost, not almost the same, but it will not be bigger a lot than it is. So in the back propagation, when the model trying to update the weights, will not change them a lot, because the problem is in the background, and you will not get very big problems in the background because we have a lot of pixels in the background. So it will be well classified. For that, you don't want to update the weights when the problem is in the background. Not update them, but not change them a lot. But when the problem is in the foreground, you will multiply your loss by this weight, which will be the probability of the background, which will be 0.9, for example. So if we have 0.9 multiplied by something smaller, so what will happen, 0.9 multiplied by something here, the error here, or the loss value, will go higher. So when the value of the error will go higher, what will happen? The weights, or yes, the weight will be updated more than that, because they see that even doing some updates, but the loss is always bigger. So it needs to update it and to make it more smaller. So this is the role of the weighted cross entropy. It will penalize the model, which means when we make the value bigger, means that the model will be penalized in the error in the foreground. Otherwise, if the problem is in the background, it doesn't need to change a lot of the weights, and it doesn't need to update the weight. So this is what I understand about that. If you want to read more about it, you can read, but that's what I understand about using this weighted cross entropy when you have imbalanced data, when you have a class having 100 or 1,000 times data than the other. So you need to do this. Otherwise, for the lever segmentation, I used only the normal loss, dice loss. I didn't use this dice cross entropy. But if you want to use it, you can just call it as we are calling this here. You can just call it dice cross entropy loss, and you give it the all the not the errors, but you give it all the values here, and it will do everything for you. And here there is a parameter or an argument called the weight, cross entropy weights. So this cross entropy weight will take the weights that as I was talking about, which will be calculated using this function calculate weights. So the return of this function will be the input of this argument, which is cross entropy weight. So you just give it calculate weights, which is the function that we have created. And here in the argument of the weight of this calculate weights, we need to give the values of the pixels, which are the number of pixels of the foreground and number of pixels of the background. And you can see here, for example, these values are from my tumor segmentation project. So you can see that there is a difference between them. So you need to use this cross entropy weighted cross entropy loss. Okay, so this is the idea. If you want to use this, you have just to change these values by calculating the weights from using this function. First you need to calculate the pixels. It will return the number of pixels of the background and foreground. Then use these values here to calculate the weights, and the return of this weight will be calculated here in this, will be used here in this weights cross entropy weights, which is this one. So that was everything that I can say about cross entropy weighted cross entropy loss. Now let's start running the script to do the training. Now let's talk about the training script. As you can see here, there is everything you need to launch your training, but I will go little bit talking about what are the differences that I did, because as I told you, I took the for loop that will do the training from Monai. So I will just, which is with this one. So I will just explain few things that I changed. The few things that I changed are I added a function that calculates, because for them they were calculating the loss for the training and the metric dice for the they are calling it validation, I am calling it testing. But for me, I added calculation for the validation or for the metric of the training and the loss of the testing. So I will get four outputs, not for output, but 4 graphs. The first one is the loss of the training. Second one is the metric of the training, then the loss of the testing and the metric of the testing. So, and I needed to save them all because I need to use them for to analyze our results, to see if the model is doing overfitting, underfitting, or something like that. So, and all what you need to know is these are the arguments that you need to put to launch your training. The first one is the model, which will be UNet for us. The second thing is the data in, which is the directory where you have your data. And yes, you have your data. And the second thing is the loss, where which loss function you want to use, then the optimizer and the max epochs that you want to do. For us, maybe we'll launch for 300 or 400 epochs. Then the model directory, where you want to save your model, trained model. Then here there is this test interval. For them, they are calling it validation because they are everything they are calling it validation. I am calling it testing. For that, I just called it test interval. What does it mean? This test interval will control in which epoch we want to save the new weight or the new trained weight. What does it mean? For example, let's just write here at the end. Let's just write, for example, at epoch 1, we will get a loss value, for example, equal 0.9. Okay, and we will save this model or this checkpoint, which are the weights. Then let's go to the next epoch, which is epoch 2. Okay, so in the epoch 2, we will get a loss equal to 0.8, for example. So in this case, the loss is smaller than the epoch 1. For that that means that the weights or the checkpoints in this epoch are better than these. So we need to save the new epochs or the new model with the new weight, which is in epoch 2. So we'll give the order that save, not, I need to add a comment. So save model in epoch 2, something like this. Okay, then we will go to the next epoch. For example, let's go to the epoch 3, and in this epoch we will get something like for example, let's say loss equals 0.85. So 0.85 is bigger than 0.8. So in this case, we can understand that the model or the checkpoint in this part or in this epoch are better than these. So we don't need to save these weights because we have already better than them. So we will skip the saving in this part. So what we will do, like don't save the model in epoch 3. So we go to the next epoch, etc., etc. So that's what always do in the training. But if you are using TensorFlow, for example, this will be done automatically if you just clone the repositories. But while doing the training using PyTorch, you can see that we are writing all the for loop by ourselves. So we are doing everything. We are calculating we need to give the order to calculate calculate, for example, the first output to pass by the model. Then we call the loss to calculate the loss. Then we call the optimizer, etc., etc. So as you can see, we are doing everything manually. So in this case, we need to do even these conditions manually. And now what they are doing, they are calculating this metric, which can be loss, or even metric, which can be dice, for example, the dice value. So something like this, and this is what they are using, actually, dice, and I use the same thing. So this dice, they calculate the dice. So more they have maximum value of dice, more than, and in that time they save the new checkpoint. But they don't calculate this dice value for the training. That's why they are calling it validation. In the training, after each calculate, or in each epoch, they calculate the new or the dice values of the testing data, which they are calling it validation data. So when they have a maximum value or bigger value of the dice from epoch to epoch, and they calculate it for the validation data or testing data, in that case they use this thing, but they do this this savings. So if this, for example, I will go here like validation, or for me testing data. Okay, so let's say that the first dice equal to, for example, 0.1, for example, and 0.1 is bad because we need it higher, we need it closer to 1. So the dice is 0.1 at the epoch, for example, epoch 1. Okay, now let's go to the epoch 2. So in the epoch 2, if we calculate this dice, it will be, for example, 0.2. So the model in this epoch is better than the first one, because here we have the epoch, Ctrl C, Ctrl V, and here we have epoch 2. But what they are doing, because if you calculate in each epoch, I am doing it, but it will slow your training a little bit, because imagine with me, in each epoch you calculate the dice of all your validation data. So you do the training, find the new model, and pass all your testing data by the model and calculate this dice value. And going from that value, you will save that model in that specific epoch or not. So to give the order, if you want to calculate this dice or to do this verification in each epoch, or in each 2 epochs, or on each 3 epochs, or something like this, this will be controlled by this what is it, the training. So that will be calculated by this test interval. They are calling it validation interval. For them, they are using this value equal to. So in each two epochs, they calculate the new dice for all the validation data for them, testing data for us, and when they get higher value, they save that checkpoint. For me, I used 1 because I prefer to calculate in each epoch, but for you, if you don't use that value, if you want to faster little bit your training, so you can put it 2 or 3 or depending on your cases. So this value 1 is by default, but when we will call the script or the training function here, we can specify it here. For me, I am not putting it, but if you want to give it, you can just write test interval, something like this, and give it 2 or 3 or anything you want, which will change that value by default. And for me, I want to leave it 1, and that was all the parameters that you need for this function. And as I told you, there is the first thing is the model. For us, we are using a a unit, but we will import it from Monai. As you can see, it is here, monai.networks.net imports unit. There are other networks, but we are using unit. So there are these 3 important things that I will talk about. The first thing is dimensions. We said that we are doing volume segmentation, which is 3D segmentation or 3D unit. For that, we need to make dimensions equal 3 for 3D. And the input channel, for us, it is 1 because we have masks with only 1 channel. I am talking about slice. Each slice has only 1 channel, and that channel have zeros and ones. But the output channels, we need them to be 2. Each, because the number of the output channels is the same number of the classes that you have. So the first channel will represent the probabilities or the pixel probabilities for the background. The second channel will represent the pixel probabilities for the foreground. Okay, and when you combine them together, you get the you get the final output. So these are the important things that we need to talk about. These are the channels which controls how many kernels or how many filters you want to put in the in the convolution blocks, and these are the strides, and this will calculate the residual units, and this one to normalize the batch. But we don't need to know everything about that, but these 3 things that are important. The first thing is the dimensions, which is 3 for 3D. The input channel is 1 because we have each slice has only 1 dimension. The output is 2, 1 for the background, second for the foreground, because we have only 2 classes. If you have more, it will be more, etc, etc. But others, here we have just to call the loss function. Here is the dice cross entropy if you want to use it. I talked about it before. And this loss function that we will use, we are using a sigmoid here. And then the optimizer, we are using the Adam optimizer with a learning rate 10 minus 5. So that's what you can use. For you, if you want to change it, you can just change the values here. You can change find multiple times, or you can just make that function that vary, which give you an interval of learning rate, and it will be changed in each epoch or each 10 epochs or something like this. But for me, I am putting a constant number. For you, if you want to change it, you can change it. It depends to you. But that's all what I will talk about here. After, all what you need to do is just run this this script. And as I told you, in this type of training, it will take time. It may take two days. That's what this is strange, but it may take 2 days depending to your machine and how many data you have and everything. And there is other things that I have talked about in the pre-process part. I told you that there is this parameter which is the cache. It can be false or true. And I told you if we put it true, means that we will use this cache function, which will load the data in the memory of the GPU. Otherwise, we will not do it. So if you have a good memory, you can just here, where is the data? This function prepare will call the data. So we can just here make cache, which is this argument, and we put it as true. So if we put it true, it will load all the data in the memory of the GPU. Otherwise it will be false. So if you put it true, it will be, the training will be faster than without the cache. But sometimes if you don't have memory, you cannot do it. So I will just delete this, because if you will do it, I will show you that it will take time even before to load the data, then it will start the training. I will just launch it like this so that you see that the training will start. After that, you can use the cache if you want. So if I will run this script, you just wait a little bit. And this is because here I am putting 20 for 20 epochs. So I will do 20 epochs, and it will calculate the dice, train dice, and it will calculate the loss for each image, as you can see here. And of course it is starting by a higher value of loss, but it will change, it will be changed. So that's all what you need to do the training. So, but you need to wait, as I told you. With GPU, for me, I have GPU GTX 1080 or 1070, I don't remember. But as you can see here, you can define the GPU that you want to use if you have multiple GPUs. So you can just change the index here. Otherwise, you can leave it like this. If you have only one, so it will be with the index 0. So that's all what you need to know about the training, and nothing else. You need just to wait for the training until it will be done. And of course here you need to specify the model there, where you want to save your model or your checkpoints, plus your plus all the thing which are here, the loss values, or the loss, yes, the loss values for each epoch, and the metric values, because we are doing here a save train loss and there is a save epoch. So this will save everything that we need. So it will save the new, in each epoch it will save the new values. So the first epoch, for example, you will get 0.9, the second epoch it will be 0.3. so it will create a list containing all the values for each epoch, and it will save them as a NumPy list that we can load after and plot it to see what was happening during the training. So that's what I can talk about. You need to wait for this training. If you want to use Google Colab, it may work, but if you are having a large number of data, it may take more than 24 hours. And you know that Google Colab doesn't allow, I am talking about the free one, it doesn't allow you to do a training more than 24 hours, depending even to your internet connection. It will not cut. So you need to be careful about doing the 3D convolutions here using 3D unit. It will take time, you need to know that. Otherwise, there is nothing else to talk about, and we will talk after the training. I will show you the results that we will get, and you will see that we will not get a perfect result, because in the medical imaging, you will never get something like perfect, or like in the other images or other tasks. But you can just see the first results after that, because for me, when I was doing it, I made tons of trainings. I launched the first one, then I tried to change something of the data, I try to add more data, otherwise try to change the learning rate. There are tons of things that you can change. I cannot talk about them all here, but because I am telling you only the basic thing and the basic code that you will find in Monai. I am just transforming some things here to make it easy, but that's it. If you want to make a better training, you need to do these changes, learning rates, or the best thing that you can do is adding more data. But adding more data means that the training will be more slow, but of course at the end it will be better than less data. So we will wait until the training will stop and try to analyze our results. So now, after doing the training, let me show you some of the results, or the results that I found for my project. So when I launched the training, I put 600 epochs, but I stopped it at the epoch 100, because I know if I will leave it into 600 epochs, it will take time. And the second thing that why I did stop the training at the epoch 100, because I found that here at, I don't know, at the epoch 100, before 100 it was in 80, 70, something like this, we get this flat here, which means that if we add more epochs, of course the training loss, it will go down and it will converge more than that, but for the validation it will always stay here. For that, I didn't want to leave the training going more than this, because we may get a overfitting, or we may get a model which is not very accurate with the validation or with the testing data. And for that, I already will show you one of the passings that I passed it by the model, and I will show you the results, and you will understand why I should stop the training here. Okay, so to do it, I have this Jupyter Notebook file that I will share it with you so that you can test your model after the training. So the things that you need to change are only these two paths: the path to the data and the path to where you save the model plus these files. Okay, if you remember, when we did the training, we need in each epoch, because I put the number or the value test interval into 1, which means in each epoch it will calculate not the training, but it will calculate the testing metric or the testing loss, the same thing, but it will calculate one of them. But for me, I did it to calculate the test metric. So when I get a higher value of test metric, in that case I should save the weights. Okay, so I should save the weights, which is the model, but in each epoch I should save the the training of the loss, the loss of the training, and the metric of the training, the loss of the testing, and the metric of the testing in each epoch, so that I can plot it like this, and you can see this evolution of the loss for the training, and these are for the validation. After doing this, now let's load one patient, or we can load all of them, but I will show you only one that I prefer to use, not prefer, but I will show you how does it look. And you can test your final model with multiple patients. Otherwise, you may not get the best or the best or the perfect model at the beginning. So you can do more changes and launch another training. Okay, so for my 100 epoch, it took me around 5 or 6 hours to be completed. Okay, so you should put this in mind. But I was using the cache, so the data was loaded in the GPU memory. For that, it took 6 hours. If I didn't do that, it will take more than that. Okay, so but it took 6 hours for only 100 epoch. I stopped it. If I left it into 600 epochs, it will take 2 days maybe. Okay, so for you, if you will launch your training at 600 epochs, for example, and if at the epoch 100 or before that, you see that your model is doing well and you don't need more training, so you can stop it. Okay, you don't need always to complete the whole 600 epochs. It is a choice, and it is a huge number of epochs. So if you see that your model is doing great before that, you can stop it. Okay, now when you want to load one of the patients, of course you should apply the same transforms that you applied during the training and the testing, of course. So these are the different transforms that we applied for the training, and the same thing I will apply it here. Then we have a test loader, because we want to load the testing files. So we load them, and of course you need to load your model, which is the unit. And after loading the model, this part here will load the weights and put them in the model, because you need to create the model first, then put the weights, or to fill the model with your weights or with checkpoints that you have saved during the training. So this one will create an empty model. This one will put the weights into that model. Now you have the model ready. Model with the weight that you can use directly for your testing part. So as I told you, I took only one patient to show you, so you can do all the changes to plot, or to show multiple patients. But you need to be careful with that, because the data loader is not like a list. You cannot just put data loader 0, data loader 1, etc. So you cannot do this. You can do, for example, a for loop. So you can do, for example, I will just write here, for patients, for example, in test loader. This one will work, And you can use this way, for example, if you want to upload the first one, so you can just add an index here, for example, and here you can put enumerate in this data loader, and you can say if I equals 0, then call this function that will plot, otherwise don't do that. This is one way. The other way that I use as well, which is here, where is it here? When you select here, I am talking about the test, but it should be test here, for example. So what I am doing here is just selecting a few patients from your data set. So if you want to show, for example, the first one, you can do, for example, 0 to 9, for example. If you want to show the second one, you can just put from 1 to 9, then from 3 to 9, 2 to 9, 3, etc., etc. For example, you can put here 9 or anything you want. So that, what does it mean? You will get a new list of patients, and always the first patient that you will get here, he is the patient that you want to show. So this is one way that I but you can use this way. Other thing, that because you cannot do like a list like here, I cannot put here, for example, data loader 0. It will not work, and it will give you an error about that. For that, you need to find another way, which is, for example, as I told you, before putting the data into the data loader, select which patient you want to do before the pre-process. You need to select which patient. So you can do that way or the for loop way that I shown you. It's up to you. But this is the way how you can do it. And this script will run on, it will pass all the patients into the model, because we said it is a 3D model, 3D unit or 3D segmentation. So it will pass the whole patient, which is here 3D, the T volumes, which is test volume. It will pass it by all the patients with the 64 slices. It will pass it by the model here in the model, and it will calculate the output or the predicted mask. And here this for loop is just to print all the slices of that specific patient. So here you can see, I will start from the wrong segmentations. So you can see here, for example, for these 4 1 2 3 4 5 6 7, we can say 7 until 8. So these 8 slices are not well segmented. Okay, so you can see that for these the segmentation is great. I cannot say perfect, but it is great. But for the first ones, it is not that good. So these are the things that you need to keep in mind. In medical imaging, you will never get something perfect, because you can see that we as human, and sometimes we cannot differentiate. You can see this, and this part is identical to this one. So you can say that this is a liver. Okay, but the model, fortunately, it is not segmenting it as a liver. But you can see that it is not easy to know which part contain, which is the exact part of the human body. So you can see that this is not bad. It is segmenting, etc. But you need to keep in mind, because you need to do a lot of changes to get more accurate. So you can maybe test these values. Maybe you can change the contrast. For now, you can put it like this. You can do another training with another values, so the contrast will be changed. So in that case, maybe some patterns will be better or will look better than these values, for example. So you can try to changing these, or the best thing that you can do is try to add more data. So you can try to add more data. You can change the learning rate. There are a lot of things that you can do, and of course you can do more processing, or you can add the data augmentation that I told you about. I didn't want to add it, but you can add data augmentation, and sometimes it works very well. So why I don't want to try everything, because as you see, even only 100 epoch took me 5 hours in my PC. So if I will try multiple trainings and multiple parameters, it will take me forever to find the best model. So, but here in this tutorial or in this course, I am just showing you how you can write the code, how you can use the different functions in Monai, but it's up to you to do different changes, to do multiple combinations to get the best result. But you need to keep in mind, in medical imaging you will never get something perfect, but I am sure that if you do more changes, more data, etc., you will get better than these. Here for this part it is good, but for example here it is missing some segmentations. Okay, and you can test it for other patients. You will find that sometimes it is good, perfect, but others is not that good. So that was how to do the training testing, how you can, as you can see, how you can see your segmentations. In the final part, what I will do, I will show you just how you can clone the GitHub repository and use it directly. So maybe you don't need to write the code by yourself, so you can just clone the GitHub repository and launch the training from it. So I will show you just in few minutes how you can do it, so that you will get an idea about that. Now, after that we have done everything step by step, now I am telling, because I told you that I will give you the code and you will find everything here in this repository. So I tried to write some sentences here to explain some of the parts, but I didn't have time to write everything. But with time I will try to add more and more explanations. And of course I am writing some blog posts about all what we were doing in this course. So if you prefer to read instead of watching videos, you will find them, but I will publish them soon, okay, because I didn't finish all the blog posts for now. So when I will finish all of them, I will post them in my website. And after understanding what we were saying, now what you need to do is just to, for example, if you want to use the same code that I am using, so you can just clone this repository using this part here. So just go here and click in this button to copy this line and go to your terminal and cd or change directory into your workspace. Otherwise, if you are using Visual Studio Code, so just open the folder where you want you to work and paste it in the terminal here, not there, and this terminal, and paste this git clone this repository. So this line will clone the repository, which means it will download all the files that you have in that repository in this workspace. I will not do this because I have already this repository cloned, as you can see here. So you will get this folder which contains all the files that you find here in this GitHub repository. Okay, so the first thing that you need to do is to install the requirements. So there is the first thing here, I am putting that, and of course when you do this, when you clone this repository, you need to cd to that repository, so that your new workspace will be this repository, so that you can directly use the code inside that repository. So just copy this cd like this and paste it in your terminal, and it will go to the next repository. As you can see here, I have already that repository. Okay, so that, if I will just make cd, and now if I will paste this cd, then liver segmentation using Monai and PyTorch, and then it will go. It doesn't go because maybe there is a problem with that, because I am putting it here wrong. So just correct this PyTorch, something like this. Okay, so all what you need to do is just to cd to this directory. After doing this, you can start installing what we used. And of course, as I told you about the virtual environment, if you need, or if you prefer to create a virtual environment or Conda environment, you can do it before installing any packages. Otherwise, if you prefer to use your system, you can do it directly, but I don't recommend you to do that. So just copy this to install Monai. After that, all the other requirements will be found here in this file, requirement.txt. So you need to install matplotlib, numpy, takaddum, glob. But when you install glob, you need to do glob too, because if you do pip install glob, it will not be installed because it is not recognizable. Then you need to install dcom to nifty, then this chantel, but before doing it, you need to type this keyword, because if you do pip install chantel, it will not be installed. And the same thing for nibabel. But don't worry about this. You just need to copy this part, which is this one, pip install -r, then requirement.txt, and it will install everything. Then after installing all the requirements that you need, all what you have to do is start coding. But as I told you, there are some stuff which you will find here. The first thing that you need to do is to convert your Nifty files into DCOMs so that you can create groups using this function that you can call with another main script which will call this function from this file. So you can just do import, create, or from what is the name, from preprocess.py import create groups, and you can just use it to create groups using this function. The same thing to convert from the DCOM to a Nifty, and to find the empty, and finally for the preparation, after doing all this stuff and creating the folders with the names that you need, which what I mean with the folder for the volume, training volumes, training segmentations, testing volumes, and testing segmentations. After that, you can just use this function which is prepare to do the pre-process, and that's it. If you want to show your patients, you can find the function show in the utilities here. I will go here. There is the function, I think it is at the end. Yes. This function will be used to do to show one of your patients. The same thing, all the functions that we were using will be found either in this file, which is preprocess.py for the preprocessing, and or in the utilities that you will find some functions to calculate the dice metric, calculate the weights for the weighted cross entropy, and this function train that you need to do. And finally, there is this function which calculates the pixels. I talk about this as well. For if you want to use the weighted cross entropy, you will need this function, and that's it. After knowing everything, you just need to call this function which is train to launch your training. So for that, there is this file which is train.py, which will call it will call this prepare for the preprocess, and it will call the train from utilities import train to do the training using that function train. So the first thing is to create the model and launch the training. So this script is like a main script to launch the training. But if you want to do the pre-process, because if you want to create the groups, etc., so you need to create another script called main or something like that to do all the preparation outside your training, etc. So after doing the training, when you need to test your model, you will find this Jupyter Notebook test.ip notebook NB. So if you open it, it will take time, some few seconds, and you will find everything we explained in the previous minutes. You will find them here, and just launch this code, but by changing here the path to the data and the path to the result or the checkpoints, and everything will work. And that's it. That's all what you need to know about this project. But if you have any questions, any problems, please don't hesitate to send me emails, leave a comment, or contact me by in social media on my website pycad.co. I have no problem answering you, but maybe sometimes I will take a few days or 1 day or 2 days to answer you if I have projects working on. So please don't hesitate to send messages or emails, and I hope to answer you as soon as possible. So I see you in the next courses. If you have enjoyed this course, please don't forget to thumbs up or leave a comment, and I see you in the next videos. Bye bye.